Okay, because we're already late, so we are going to start the first session today with James. We are going to talk about modernizing your IP strategy and how we can do that. So welcome, Mike. Oh, James, sorry. And the mic is yours.
Thank you, Sarah. Good morning, everyone. I hope you're all well and have had your morning coffee. So my name is James Kennedy, and today I'm going to be speaking to you about IP addressing matters. But before I get started, I'd like to ask the room who are here, how many are IP operators? Please raise your hands. Okay, a few. Please keep your hands raised if you have deployed IP version 6 in your environment. Fantastic, most of those hands stay raised. Final one, please keep your hands raised if IP version 6 has reached parity with IP version 4 in your networks and services, or even has become the more dominant protocol. Traffic volume counts. Okay, so those who kept their hands raised, you are ahead of the curve in many aspects, so congratulations to you. I'm going to share with you some insights on some interesting IP trends in the markets, in the transfer areas, across the landscape, and also some best practices from my experience on how your organization should be operating in this space. So first of all, quick introduction. Yeah, I've been working in the wonderful world of IP addresses for 15 years now at this stage. I've worked for mostly at that time with Beirut-IX for 9 years. I was leading their IP address management discipline across the 13 operating countries in Europe. I also worked for Amazon AWS and their IP strategy team, and more recently as CRO of their IP NCC. This year I started a consultancy, independent and vendor neutral and broker neutral, and with the mission to help organizations develop smart IP strategies and to mature their IP ecosystems and capabilities. So, how is the IP landscape evolving? Taking a look back to the early 2010s, there's been many, obviously, events and milestones that have helped to shape the landscape over the past 10, we'll say 20 years even, but I just want to focus on a few specific developments, shall we say. So, yeah, back in the early 2010s, the OREOs began to run out of their free pools of IP version 4 space. Smart organizations out there stockpiled what they could, and the IP version 4 market was born. From then, the early adopters with V6 started to get motoring, and they targeted network launches. Then, as a rough gauge, between 2015 up to today, those organizations that have launched IP version 6 on their networks are migrating their IP version 4 customers, residential customers and services to IP version 6, and in doing so, freeing up those IP version 4 pools within their organizations. And today, we're now at a moment where brokers are reporting more supply than ever before in the market. So those freed up pools within organizations are now seeping their way into the IP market, which is feeding supply and meeting demand. So before I go into looking to the future, no one has a crystal ball, of course, but just to look at the two, we'll say, extremes of what could happen, two ends of the spectrum. So we'll say IP version 6 goes into overdrive, driven by hyperscalers, cloud, AI, Internet of Things, and maybe the rest will follow suit. That could be supported with IP version 6 only regulations. We know in the Czech Republic have got a very aggressive mandate for V6. And also there could be other incentives and networks going IP version 6 only. The other end of the spectrum, who knows, maybe an IP version 4 renaissance. So large-scale recycling of resources across organizations, again, feeding their way into the market. In doing so, driving down the costs where it gets to a point where potentially, deploying a certain large new project or service next year for organizations becomes cheaper to do with V4 rather than V6. Policies and market mechanisms could potentially follow suit. Again, two extreme ends of the spectrum. What's more likely is where we are now, a progression of the dual stack world that we're in, with IP version 6 growth continuing and IP version 4 market developing and evolving. So a quick look at the IP version 6 adoption stats. I'm sure many of you are familiar with. So on the network side is where most success with v6 is happening, particularly with the traffic. So there's parity being reached with internet traffic, v6 and v4, almost 50% share each, which is fantastic. The networks themselves, 50% are v6 enabled, so they could obviously get to 100% and also with their v4, so it's not a zero-sum game in that aspect. The content side is where things, v4 inertia is really more being felt. So as an example, the website support for v6 is currently at around 30%. So that's an area for growth for sure. Challenges ahead. So I've put number 1 here, return on investment. You know, there's many competitions for budgets nowadays, what with AI, cloud investments, you know, security, cybersecurity investments really grabbing attention. So for organizations who have, we'll say, enough resources or have, you know, their CG NAT configurations that they're happy with, they see more v6 as being a nice to have rather than must have. So there's areas for, we'll say, business incentives. Technical debt and compatibility, so dependencies both internally on your infrastructure and externally on partners on v4. Operational complexity, so running the both protocols in parallel comes with its own challenges. And yes, as I mentioned earlier, the market in IP version 4 recycling as a whole, which is what I'd like to hone in on. So what is actually happening to IP version 4 in the meantime? So looking at a very high level, the number of addresses that have been allocated by all of the RARs stands at over 3.5 billion IP version 4 addresses. So most of that is with ARIN, which has got pretty much the same amount as RIPE and APNIC combined. Of those allocated resources, 84% of the blocks, over 3 billion in IP address count, are advertised on the internet. 16% not, so over 500 million. So these address, what interests me here is the not advertised blocks. Now, some of these could be used internally for various usage and not being announced on the internet. But conversely, there are blocks that are announced on the internet that are actually not being used internally. So the reasons some organizations do this are for security reasons, also for reputational reasons. But yeah, the main point here is, yeah, there are still, we'll say, blocks, we'll say, unused IP, version 4 IP space out there. When it comes to transfers, here's some stats from the overall figures. I've taken these figures from the FTP sites for transfers with all the RARs back to 2009. 2014 is when things got interesting, so I've included only from there. ARIN, unsurprisingly, takes up the majority share here. Nothing particular I want to highlight. 2025 number address counts being transferred is as high, consistent as has been in previous years. 2018 does stand out, but that wasn't through the market. There was some major merges in telcos in the US that caused this large spike. Here's a number of actual transactions, so transfers. For reference, again, consistent with previous years. For me personally, it's much more interesting to see the IP address count that's been transferred. So one transfer is not equal to another transfer. We could be talking about a /24 of 256 addresses, while one other transfer could be a /8, potentially over 16 million addresses. So they're not one for one. So the real value in these numbers are with the IP address count transfers. And just as an interesting stat, almost 1.5 billion IP version 4 addresses have been transferred since 2009. That's almost 40% of the total volume of global v4. Of course, they're not the same, not unique addresses. There's going to be several transfers that will be repeated for the same blocks, but still, it's an interesting stat. Inter-RAR transfers. So previously I showed you all of the transfers that have happened since 2009. Now let's have a look at the transfers which has happened between ORIORs, so organizations transferring from one ORIOR to another. They could be the same organization or different, but it's about the movement of blocks between the ORIORs. And in this space, RIPE is really dominating. So previously I showed you the amount of resources being held by ARIN transactions. On the inter-ORIOR space, RIPE has a disproportionate amount. So they have received over 91 million addresses from other ORIORs, particularly from ARIN, which is 82 million count, which is more than 50% of the total share of addresses being inter-ORIOR transfers, which is interesting. The reasons for this are pretty well known, I believe. So there are cheaper ORIOR fees for organizations that hold a large bulk of resources. So RIPE service scheme, charging scheme is currently a flat charging scheme. Other ORIORs charge by how much addresses you hold. The IP version 4 policies in the RIPE region allow for IP leasing, while in other ORIORs it's either discouraged or prohibited completely. And yeah, it raised the question if RIPE is becoming the global hub for leasing. Here are the annual inter-ORIOR transfer in IP address count. You'll see over the past 3 years that there's an exponential growth here, which caught my attention. The growth from 2023 to 2025, you'll see. ARIN are receiving more inter-ORIOR transfers, it seems, in the past 3 years. RIPE numbers are consistent. I didn't have enough space to add the detail, but if you're interested, I'll share more details after the presentation as well. So yeah, the point here is the IP blocks are flowing freely globally. The IP version 4 market, so a different side, on the leasing side of things in the market. So leasing is an attractive option for some holders of address space that have idle resources that want to generate some revenue, but keep holdership or ownership of the resources. So from the IPXO public website, I took this download 2 months ago, again showing an exponential growth in the leasing domain over the past 2 years. Now, there is a bit of a challenge when it comes to leasing. There's a lack of transparency, which is unlike transfers, so permanent transfers opposed to renting or leasing. For transfers, they're published, they're processed through the ORIORs, and their details are published online. While with leasing, it's at the discretion of the holders how they want to register the leasing within the, we'll say, RIPE database in our region. Makes it challenging for policies to keep abreast and to adapt to any changes that may need be. And just for the full picture, to complete it all, the pricing, 2021 was the peak. They were looking at almost $60 per IP address. That has fallen by over 50% since. And there was, I remember it was raised yesterday if this is what's driving this. It's, as I said earlier, I spoke to a couple of brokers, prominent brokers, and they're saying that they're receiving more supply than ever before in the market. So it's a normal market dynamic where supply is meeting demand. And leasing, get out your calculators to calculate the monthly rates for leasing. So what does that mean? We live in a dual stack world already. V6 is growing, and the V4 market is evolving. And also within organizations, the recycling of resources, of V4 resources. There are options for organizations out there who need or hold public IP capacity, and some key considerations to take into account when evaluating your requirements. I won't go through these in detail, but they're self-explanatory as well. But for me, the foundation, what I see sometimes being overlooked, and where there's an awful lot of value to be gained, is by, first of all, ensuring your foundation is in good condition, so maturing your internal IP system. So what do I actually mean? Sorry if I skip too fast. So second part, maturing your IP system. What do I actually mean by this? Well, for me and my experience, I broke it into 4 main categories. Number 1, the governance and accountability. So who's responsible for what within your organization, ensuring you have the right policies, not too tight. You know, you don't want to inhibit on innovation and scalability, but ensuring that your resources, you're getting your value, and your processes are in place, your cadence. So twice per year, for example, in Liberty-Global, I carry out a thorough IP audit with the countries, operating countries, every March and September. I send them the emails. We kick off a thorough audit for that month, reflecting on their current status and trends and their forecast for the requirements for the coming year. And that was iteratively improved with every cycle. Then comes to tooling, of course. So IPAM tooling and visibility. There's many IPAM solutions out there with great functionality, but you know, it's still a tool, and how you use it is the most important thing. So from a single source of truth, you do need that repository with the proper naming and tagging conventions, proper discipline across your organization and your IP leads to ensure that they're following through, and the appropriate level of granularity. Now, we're not talking about host level. Those you have CACT and other tools to. We have DHCP and details, but you want your central repository for everyone to sing from the same hymn sheet. From there, you can develop your analytics and forecasting, of course. So you need intelligent reporting and measurements on the status of your IP ecosystem, and also, finally, strategic planning and project capabilities. So, you know, targeting, migrations, optimizations, efficiencies, and automation where you can. So now I'm going to briefly bring you through 4 examples of what I mean, how this transpires in real life. So smarter forecasting. As soon as I arrived in one of my former organizations, one of the operating countries raised the alarm that they're going to exhaust IP version 4 in 3 months, and they wanted another /16 from the central bank. So after reviewing how they determined this, there was some high level, we'll say aggregated measurements, and only using trend-based forecasting. Now, this is problematic, as you know, within every season you can have different trends as well, so this was inconsistent. So immediately we got together an emergency team with the central, local, finance, engineering, business planning teams, and we did a deep dive, split pools per service, and then per service type, get the RGUs from the financial team, so they're the experts in knowing the expected RGU revenue generating units and IP users for the coming year. Seasonal growth trends were taken into account, not just the peaks, and scenario-based projections as well, so impacts that will have on your IP space consumption. Result, smarter forecasting, thankfully, so we could target that between the 3 service pools, primary per service pools of residential, B2B, and infrastructure. Residential was the one which was the most, we'll say, in trouble. So we broke that down into 3 primary regions, one being the most metropolitan in the country, which was consuming the most space. And by doing so, we added 6 months to our runway and of the exhaustion of V4 runway, but also accelerated the IP version 6 launch. So within the IP version 6 program within the organization, we accelerated that to be priority. And you know, return investment was immediate. /16 was saved in the central bank, retained with the market value of $1 million at the time. So key lessons: proactive analysis beats firefighting, which is obviously we know. Critical factors: collaboration across teams, proper IP tagging, scenario-based forecasting, and getting the proper inputs from your experts within your organization. Example number 2, IP version 4 recycling. So again, we had an organization who required a /16 for a new service in the following year. Their free pool was very fragmented, and time is okay. Their free pool was very fragmented, had about a /16, but it was 65,000 addresses, but in very smaller prefixes. Requested my assistance with going to the market to purchase a /16. Now, always my first question is, do we really need it? What's the current, utilization rates internally? Prior audits did indicate that there was significant reserve space within their B2B, the business IP pool in particular. So there was a problem of granularity, so there was no real insights beyond, we'll say, the registration in the central tool, and the leadership visibility was poor as a result. Again, conducted a thorough investigation, audited all the reserved pools across the business, challenged those reservations, the justification for those. Of course, found multiple blocks that were reserved for cancelled projects, quarantined for migrations, and unnecessary stockpiling. So we freed up, aggregated contiguous space as much as possible, feeding into also the prefixes in the free pool, and released what we could. In doing so, recovered again /16, market value of 1 million return investment, and in doing so, we developed the, we'll say, processes and governance responsibilities of how space should be properly managed within the organization, and gave leadership greater visibility and control. Number three, example number 3, V4 to V6 migrations. So across the organization, once we rolled out IP version 6 DS Lite, there was a goal to optimize the AFTR and IP version 4 capacities without impacting service performance. So the strategy to do so was by customer segmentation. So we identified the customer types that would be suitable for IP version 6 DS Lite that weren't going to be impacted, we knew. And those were, we'll say, profile B, as you see. So they're standard users with no special requirements. Meanwhile, for profile A, for residential users who had special features, port forwarding, who were gamers, they still required IP version 4. So then implementation, customer profiling for the countries that had launched IP version 6 DS Lite. Any new customers that were fitting into profile B were added on IP version 6 DS Lite. Others were on profile A. That was done for all new subscribers for a certain period of time. Then there was a large cross-country program to migrate existing customers who fitted into these categories, and migrate those who were in profile B to IP version 6, but also, of course, having a rollback mechanism and a playbook for the customer services department. So if there are any issues, any calls in, dials in, you could fall back to IP version 4. Outcome of this, we'll say, cross-European program, there was millions of capacity, IP version 4 capacities freed up, which saved, obviously, runway, and at the time in particular, there was quite a lot of pressure for IP version 4 exhaustion across the footprint. Customer satisfaction was maintained, and return investment was, avoiding the expensive market purchases and sustaining our scalability. Finally, IPAM automation, with more straightforward, major program across one of the larger countries. CMTS upgrades required some IP scope swapping, very manual work, unfortunately, glorified Excel sheets and multiple checks across multiple systems, costing us 2 FTE in our IP planning team. So solution was to develop a automated IP scope checker. So single interface where you can input your prefixes, you'll get the status of that prefix across the multiple inventories and checklists, and in doing so, developed also a rules-based IP assignment logic. The outcome of this project was we recovered, a 1.5 FTE, so half an FTE was enough to actually manage this on their own from then on. It was faster site turnaround for the IP scopes, and the risk of errors were reduced drastically. And of course, the tool is reusable going forward again, so efficiency gain. So beyond the financial benefits of optimizing your IP space, of course, there's strategic value across your operations. Also for strategy, if you want to be smart about your IP resources and consider your options, having good control and visibility and optimization across it is important. Capabilities as well, intelligent forecasting is critical for every part of business, but also in this area sometimes gets overlooked, but make sure you get that data accuracy. And ensuring that your readiness is in place, so it's more of a strategic transformation rather than a simple cost-saving exercise. So, in summary, key takeaways, dual stack is the reality, it's where we are today, and I, like many others, believe that's going to be the case for the next decade at least. V6 is growing steadily, but also the IPv4 market is actively evolving, so plan for both. Internal capability, maturity unlocks external optionality, so as I just showed in the previous slide, not just for financial reasons, but also for operation and strategy planning, there's a lot of gains to be made. And as I said before, foundation beats firefighting. Make sure your governance, your IPAM visibility, for intelligent forecasting, your efficiency, targeted efficiencies are all in place. And proactive analysis beats emergency purchases. So with that, I think I'm good for time.
Yes.
I welcome any questions or comments.
Thank you so much, Jay. Thank you so much for the great presentation. Do we have any questions, comments,
Don't
feedback?
be shy. It's a safe space.
Okay. Okay. Thank you so much. Thank you. And next, we will have Dominique in the stage, and we are going to learn how two new modern technology so that you can deploy in your internet exchange point, so it will make your internet exchange point greater flexibility and more scalable. Welcome. Introduce yourself.
Thank you, Sarah. Can you hear me well? Yeah. I took another mic because I move sometimes, so anyway. So let me introduce myself again. So I'm Dominique or Dom Schaeffer. I'm heading the consulting engineering team in Nokia. So that's basically a team looking after all the portfolio. And I'm based in Paris, so sorry for my accent, right? And I'm going to present move to EVPN on segment routing. So basically, is there some echo? It's only me. It's okay? Okay. So I'm going to present why it can be interesting for IXP to move to EVPN on segment routing. So we'll first focus a little bit on EVPN, and afterwards we are going to discuss segment routing, both MPLS and also segment routing V6, okay, and see a little bit the difference. So, okay. So first, what are the challenges? Okay. What are the challenges for the IXP? So at the end, to summarize, an IXP, it's a big layer 2 switch, right? I mean, of course, it's a big picture. There's other services, but this is the main one. And what is expecting here, it's that all the traffic between the different customer exchange well, but also to have the BGP route exchange between them, okay? All the other traffic could be considered as noise, right? So those noise, like unwanted protocols, like broadcast and non-multicast, it's something that can be extremely disruptive and that you want to remove, okay? The other thing that is quite important, it's the fast convergence and the reliability, of course, and the redundancy that is needed, right, globally, to ensure the services, right? So today, majority of the IXP, and we have a lot of IXP as customer, are using VPLS based on TLDP, okay? So when you use VPLS TLDP, the challenge here at the end is that you're doing all the MAC learning in the data plane, okay? So EVPN can solve this challenge by really learning all the MAC addresses in the control plane. So basically, you will have no more flooding into the network of ARP requests, for example. So just to illustrate this, you see here, well, I think you learn IPX on MAC-Y on router 1. So if it was, so what happened with EVPN is that it's propagated via BGP to all the routers, right? So that means that if there's one customer behind router 3 that is here, what will happen is that it will request to go to IPX, there will be an ARP request, and with proxy ARP enabled for EVPN, because it was already transferred to every router, it's router 3 that will answer directly, right? Instead of flooding all the traffic inside the network. Correct? So that's very good, because if you see on the left, this is examples of enabling this proxy ARP. That's from DeKix, that was presented by Thomas King in 2024 in MPLS Congress, where you see here the full traffic of inside the network in terms of broadcast and non-multicast. Here you see migration to EVPN with proxy ARP, and you see that there's a drastic drop in broadcast and non-multicast traffic, right? Same below. Here it's one of our customers also, that is IXBR, that is the biggest IXP in the world, in Brazil, in terms of throughput. They're using, I mean, it was presented to LACNOG in Latin America. Basically, you see on the left before enabling proxy ARP and after, where the traffic really dropped, right? So this I mean, what is the benefits of this with EVPN is that really it reduces all the broadcast and non-multicast traffic, but it also brings security here, right? So now, is this enough? Just EVPN, classic EVPN? No, we also need an extension to EVPN to be able to transfer some attributes that are needed for IPv6 and for static route. Basically, I'll explain. You have two RFC dealing with this, and the RFC 9047 is defining an extended BGP community in EVPN to be able to transport some flags. There's 3 flags that you can see here. The I flag, immutable, the override flag, and the router flag, okay? And what is this? Basically, before this extended community, it's something that you couldn't do. Basically, when there's a PE that is snooping a network advertisement in IPv6, you have, for example, the router that is also here. Before, it was not possible to transfer it to others. So with this extended community, you are also transferring this router or override bit, and it can be populated in the ARP table here, or I mean the ND table, okay? That's one thing. And the other thing, it's, for example, if you are learning the same IP from different routers. So imagine you have one router where you define statically an IP address and a MAC address, and another router where you learn dynamically the same IP address with a different MAC address. For a third router that received the 2 advertisements, it doesn't know which one to choose. Okay? So here, what this extended community is doing is that you're setting the I bit when it's a static, because what you want, of course, is to select the entry that has been done statically, because obviously the dynamic one, if it's the same IP, it's a problem, right? So in this case, the third router can choose the right one easily. because there's the I bit that is set, immutable bit. Okay? Now, on top of this, you can also configure for the security part. You can configure, of course, IP on MAC list. That's more security also for IXP. So configuring IP on MAC list to ensure that the IP is bound to one MAC only. And that, so in this case, you can turn off the dynamic learning of IP MAC. You have option of EVPN flood options, right? Where you can prevent any flooding of unknown ARP request, okay, or gratuitous ARP. And you have also the notion of sponge MAC. So what is a sponge MAC? Basically, it's when you have an unauthorized IP, for example, that is not in the list. You give back to this request a sponge MAC that you have configured. After this sponge MAC, what you do with it, it's at the end you can drop the traffic when you receive a destination to this MAC, or you can also send it to a collector for further analysis, for example. Okay? So those things in EVPN is enhancing globally the security, right? So why would you move to EVPN? We already saw some things. So the first things I already explained, it removes really all the broadcast and non-multicast noise traffic. Enhanced security, we just saw that. But the other things that bring EVPN also, it's a standard way of doing all active multi-homing, right? That doesn't exist in other protocol. It's the only one that is standard. When you're multi-homing to two different routers, in a lag, for example, today you can use MC lag that is proprietary, but normally it's only one link that is active. With EVPN multi-homing, you can do all active, right? You can do you can load balance between the two links, and this is in a total standard way, right? This is really good for EVPN also. It's a future-proof protocol. So why I'm saying this, it's because at the end, if you look, there's no more, I mean, from every vendor, right, including Nokia also, we don't put a lot of emphasis in developing in VPLS TLDP, right? All the new development for layer 2 VPLS is going into EVPN today, right? The other things that we'll see just after is that it's ready for SRv6. Because if you want to use SRv6, you cannot use TLDP anymore. You need to use EVPN, right? It's mandatory. The automation capabilities, what is this? It's that if you do normal TLDP today, what is happening is that you need to configure manually all the LSPs, right? Normally, except if you are using VPLS auto discovery. With EVPN, it's like IPVPN, it's totally automatic, right? So you don't need to configure the LSP. It will be based on route target automatically. There's also an RFC that defines a smooth interworking between on the integration with VPLS. You have full tooling around it, around the EVPN for port hygiene. And you also have techniques of loop protection with black hole MAC. So basically, you can monitor in a period of time. If you learn the MAC, like, I don't know, 5 or 6 times in 1 second, there's a problem, right? It means that the MAC is learned here, and after another things, there's probably a loop somewhere. So in this case, automatically, it will black hole the MAC, okay? And you can define a period of time also, how long the MAC is black hole until it's coming back. And again, if you see some change in the MAC learning on one side, on the other side, etc., it will black hole again. Okay? So I think the next, yeah. So that was it for, oops. sorry. So that was it for EVPN. So you see that there are some advantages to move to EVPN. So now let's move to segment routing. So just one slide of introduction. Basically, what is segment routing? So it's a tunneling mechanism. Okay, it's like LDP, it's like VXLAN, it's like RSVP, based on source routing. How does it work? Basically, you're defining segments. The segments can represent a router, it can represent a link, and can even represent a service, right? The good thing is that it's transported in ISIS and OSPF, so it's an extension to the IGP, and there's no more LDP, right, for example. So you have two flavors of, I mean, even more, but you have two flavors of segment routing. You have the segment routing MPLS, where you leverage on the MPLS data plane. And you have also the SRv6, where it's a totally new data plane based on IPv6. Okay? So just an example, how does it work for the segments? If you want to go from R1 to R6, you just need to encode one segment, this one, and it will follow the IGP, okay? If you say, okay, I want to go to R6, but first I want to go through R3, like kind of traffic engineering. In this case, you will need to encode segment of R3 and after R6, okay? So when you want to pass for a link or a router, you need to encode the segment. So in my example here, R3, R6, there's two segments. So in MPLS, it would mean that you would need to stack two MPLS labels, okay? In SRv6, so here there's different flavor, but the trends of the market is the micro-SID, where you're compressing the IPv6 header. It means that with one IPv6 address, you can put up to 5 segments normally, okay? And if you're interested on how is working micro-SID, I think there's a session after from my colleague from Cisco. And there's also in the backup slides, I also put some slides to explain a little bit more how micro-SID is working, okay? But that was high level on the segment routing things. So let's compare a little bit both way of doing SRMPLS and SRv6, micro-SID. So first of all, in terms of IP infrastructure, you need, for MPLS, for SRMPLS, you're using the same data plane as today. You can use IPv4 or IPv6, whatever you want, okay? On SRv6, of course, you need full IPv6, right? I mean, IPv4 doesn't, you cannot do it on, you need IPv6, so there's no choice. On traffic load balancing, that's good things, because if you have multiple lags, for example, when you want to load balance in MPLS, you usually need to insert an entropy label or hash label. Okay, so hash label is called FAT also, and entropy label is entropy label. In IPv6, you have directly in the header of IPv6 a flow ID field, so you can load balance on it very easily. So, for example, this is interesting things because that was one of the drivers of IXBR, for example, so in Brazil, to go to SRv6, because they have multiple vendors. And some vendors in MPLS, they were supporting only entropy label. Some other vendors only FAT label. So at the end, there was no interoperability, right? And with this, it helps really to have the same way of load balancing, okay? Now, in terms of services, over MPLS, you can put any services. You can use also TLDP and things like this. On SRv6, as mentioned before, you need to use EVPN. Huh? You have no choice here. You cannot use TLDP anymore. On the traffic engineering, you have multiple ways of doing it. You can use FlexAlgo, you can use PSEP, so a controller. well, I will not go into detail here. Interworking with legacy services, there's multiple ways, but for SRv6, it's a bit more complicated because you don't have the same data plane anymore. In terms of intermediate nodes, if you're not doing traffic engineering, you can have all the nodes in the middle that do only IPv6, so are not aware of anything else. For MPLS, of course, you need the nodes in the middle to be able to do MPLS. Okay. In terms of skills and training, well, that's a little bit the difference because today MPLS is here since more than 20 years. You have a big operational team that knows very well how it works. Going to SRv6, well, it's a bit more complicated because it's new, right? Basically, micro-SID is since 2021. Segment routing, MPLS, is since 2014. And MPLS is since more than 20 years, right? So here, you need a little bit different skills in terms of troubleshooting. And in field proven, it's what I just said. Today, we have the vast majority of our customers that are going to SR MPLS, mainly because I think SRv6 is quite new and it's more cumbersome for the migration, right? But there's a trend globally to go to SRv6 also. At the end, both protocols will achieve the same thing, right? Okay. So I didn't put migration to MPLS here because it's very easy, right? If you want to migrate from LDP to segment routing MPLS, you just need to change the tunnel, the priority of the tunnel. There's nothing to do in terms of data plane. For SRv6, if you want to move from TLDP to, from LDP to SRv6, it's a bit more complicated, but there's no problem to do it, but it's more a project in itself because it's different data plane. So there's two options here, or you have like a dual plane approach where you have routers that are doing only MPLS and some other routers that are doing MPLS on SRv6. So at the end, routers that are doing SRv6 will communicate by default in SRv6. Now, if this one is doing no SRv6, it will use MPLS. Okay? So this is during the migration period. Of course, you need your node to handle the dual plane, and there will be more resources needed for that, right? Another option is to use a gateway. So for example, for a VPLS, it means that you define a VPLS with one side that is MPLS and one side that is SRv6, for example. Okay? What we see more in our customer, it's this option one, okay, in terms of dual plane. So why would you move to SRv6 or segment routing globally? So the main driver is the first one. It's to increase the network resiliency. Okay? Today, when you're using LDP, you're not sure totally about the convergence time because you can use LFA, so loop-free alternate, to converge in 50 milliseconds, but it depends on the topology. With segment routing, you can use TI-LFA, that is topology independent loop-free alternate, right? So you're sure that you will have 50 milliseconds in all cases, right? In terms of troubleshooting, it's also nice because if you look, that's for MPLS, if you look in LDP, you will change label at each router. There's a swap, so it's difficult to follow the full path. With segment routing, the MPLS label that will be used will be consistent across all the network. Okay? For IPv6, it will be the same IPv6 also if you use the segment routing without compressed. If you compress, it's different because the IPv6 is modified. Okay? You can also have good visibility of the traffic because you can, by segment, you can look, by segment ID, you can look at the traffic statistics, so that's very good. You can, of course, change from LDP. It's that you can do traffic engineering easily. So at the beginning, you can start without traffic engineering, and after, enable it if it's needed, with BGP policy, with FlexAlgo, or with controller. So you can use the controller here. You have no more LDP, huh? So, and you also have no more issue with LDP, IGP sync. In big network, it can be impacting. Huh? We have some feedback from some customer that's quite good also, that they remove this problematic. And the load balancing, we saw it. Huh? It's easier with SRv6, right? Okay. With IPv6. Huh? Okay. So if you want to learn more about segment routing, we have a book that is totally free. You can click on the link. So it's Colin, that is in my team, that wrote it. It's a book explaining very well segment routing, MPLS, segment routing v6, everything. Of course, you have an example of Nokia CLI, but it's very didactic and very nice. It's also regularly updated with the new features that are coming. Okay. The other thing that is quite interesting, it's Container Lab. So that's a way of testing the full, if you want to test, for example, segment routing or something else. We developed initially as Nokia a tool that is called Container Lab. Basically, it's a way of doing lab as code. Now it's full open source. So it's, we put this back to the community. There's a lot of people contributing to it. So what is it? It's basically, it was presented 2 days ago also here, right? It's a way of doing lab with infrastructure as code. You can use any, as soon as you have a virtual machine of any router, like, it can be Nokia, but of course it can be Cisco, Arista, Juniper, whatever. When you have a virtual machine or a container, you can use it and develop your lab very easily on your computer, for example, or on a server. You define it in a YAML file with some topology, with the nodes. It will be, all the nodes will be in a container. If it's a VM, it will be containerized also. And you define after some links where you want to link together all the routers. The very nice thing is that there's a lot of tools around that. Like if you are used to use VS Code, for example, you have VS Code extension for that, where you can display the full topology, where you can do a Wireshark, etc. And it's very good for that. I was using before FNG on GNS3, like a lot of, like many people. But with this, the good thing is that it's infrastructure as code. So at the end, you can share your lab with a customer, with a colleague, very, very easily, right? So you can just, if you transfer, if you give the YAML file to someone on the configuration, the lab, it can just spawn the lab in a few seconds, right? And that's very good. There's also a Discord server for this, where you can ask questions, right? So that's it for me. If you are using Container Lab or if you're interested, I have some stickers if you're interested. But yeah. Well, okay. Thank you very much.
Thank you so much.
Any question?
Yeah. Any questions? Thank you so much, Dominique. That was very useful.
This is Saleh from Salat. Thank you for presentation. My question is, what is the benefit of moving to SRv6 if the segment routing, the normal segment routing, it's working fine? Do I need to remove to SRv6?
You mean if you are using SR-MPLS today? If you are using segment routing?
Yes.
No, honestly, there's no driver for me. Because at the end, SR-MPLS and SRv6 achieved exactly the same thing, right? Now, if you're totally greenfield, or you want, or maybe you have engineers that wants to test something new, why not? But there is no need today from one to the other. If you look at the industry, I mean, there's a lot of trends around SRv6 globally, and I think you're going to talk about it afterwards. But if you look at the global deployment in the world in terms of service provider, it's quite low. And why it's low? It's because adoptions of new protocol is taking time, first of all, right? On SRv6, it's from 2021, so it's still quite new. I mean, it's a little bit from before, but really the industry converged to compressed seed with micro seed in 2021, right? Micro seed and even G seed also, but anyway. And so, is it the next step after SR-MPLS? I would say no. Choose what you want, SR-MPLS or SRv6. Today, I would say, I believe 95 or 90% of the customers, it's SR-MPLS, because it's around since 2014, right? Oh. Does it answer your question?
Yeah.
Okay.
Thank you.
Dominique, merci. Interesting talk. My name is Nishal Gobardhan. I'm from IXPs. We're an internet exchange points in South Africa. We're a recent Nokia customer. Happy so far. And we're in the process of making the migration to EVPN with VXLAN. So I'm a convert of that. And the first part of your presentation, I understand very well, because I see the value that we're talking about as an internet exchange point operator. But also, as an IX operator, I'm asking, I'm unsure of the value that segment routing is going to bring to me. I'm not a segment routing expert. Old hat at IP, but not an SR expert. And my reason is, there are about, what, 825 or so internet exchange points across the world. Most internet exchange points operate within a very small geographic confinement. And my understanding of segment routing is the ability to signal routing, source-based routing, which is very, very useful to an internet service provider who is operating on a multiple country, multiple region basis. That's amazing. But for an exchange, which has a much smaller geographical scope, I mean, I'm really trying to understand, me now as an IX operator, in my build plan, I really tried to read slide 10, and most of the benefits that what you were talking about were more benefits about moving away from traditional MPLS, which I understand. I just don't, it's not connecting in my head the value that SRV...
No, thanks for your questions, and I fully agree with you. I mean, the segment routing things, it brings value in terms of convergence time, for example, as I said, right? The TI-LFA. That's global MPLS on SRv6, right? It brings value in terms of load balancing, but in this case, you need to be big, indeed. So for a small IXP, as you said, if you don't have all those problems of big load balancing, you are not thinking about doing traffic engineering in the future, I think VXLAN is totally good, right? I mean, I presented both. It doesn't mean that you need to go both, right? EVPN is for sure very good, and I think it's the key things. The first thing to do is to move to EVPN, because it brings security, and it brings all this noise removal from with proxy ARP, right? After, segment routing is a possibility. We had, as I mentioned, IXBR, but this is big. It's the biggest in the world, right? In terms of things.
It's also distributed.
It is indeed, and they want to do traffic engineering maybe in the future. They are doing a lot of load balancing, and here it makes sense. If you don't need that, I think VXLAN is very good also, right? Or LDP. I'm not saying that you need totally to move all your things there, but there's a possibility if the advantages of segment routing that I just mentioned is something that is interesting for you, right?
Okay. All right. Thank you. Yeah. Interesting talk.
Yeah. Thank you. Any other questions? Or?
More questions? Okay.
Thank you very much.
Thank you so much, Dominique. And the last talk will be for the first session with Ahmed, Abdelsalam. And we are going to dig more about SRVC.
Yeah, you want it?
Yeah. uSID.
Yes.
And we are going to learn also about two key use case study has been currently defined on IETF with Ahmed. Ahmed, introduce yourself. And
Okay.
thank you.
Good morning, and thank you for the introduction. So my name is Ahmed Abdelsalam. I work in the segment routing team at Cisco. And today we're going to talk only about SRV6 and basically how it enables new use cases like deterministic path placement in the AI backend and having a unified design for the DC frontend. I don't know how much you are following now in the news, but everyone is talking about AI, definitely. And in September this year, Microsoft has announced their largest AI DC data center, the Fairwater DC, a DC that runs hundreds of thousands of GPU. That was in September. In October 2025, this year, Gohan from Microsoft at the OCP conference explained the key enabling technology behind this largest AI DC in the world, which is SRV6. And he explained how they use SRV6 in order to do placement of flows in the AI DC and how they could achieve optimal load balancing on this. We're going to talk more about how this is done in the AI DC, but before we go into this, let me remind you what is actually SRV6 microSID and what is the problem it solves. And here, it's really back to the IP protocol that we all use. Basically, we use IP everywhere, from, let's say, from streaming, from workload in the cloud, from, let's say, your sensor, all of the mobile industry, everything is over IP. But the problem with that IP protocol that basically was one of the greatest inventions in the digital communication industry up to now is that it has been designed to be a best effort protocol from the beginning. So it's just a way to identify devices in the network. And everything that you need to do on top of the IP protocol, you need an extension. So that's how it looked like in the past. So IP is just destination address. It identifies my device in the network. Anything I need to deliver, any service on top of IP, I need to define a new extension or a new shim layer and per domain. So the industry have done MPLS in the core in order to deliver services and do traffic engineering in the transport, VXLAN in the data center, GTP in the mobility, NSH for the network function virtualization or the service chain. Unfortunately, this protocol, because they were defined per domain, and since they were not native in IP, they came with their own issues and problems. And one of the first things that you lose, for example, when you use MPLS, is the scale. Because in MPLS, there is no summarization. So all of the prefixes are /32. So one of the key scaling properties of IP is the summarization, and this is something that you lose. But then you go in the data center with VXLAN. In VXLAN, there is no traffic engineering capabilities at all. And people used to say, yes, but there is no traffic engineering requirements in the data center. I just to give you one example of how people use SRV6 inside the data center to do traffic engineering of the AI flows. But this is not only the only issue. The problem is that whenever you have to deliver any end-to-end service, because this is what you want, you have to cross multiple domains, and in order to cross those domains, you need interconnecting gateways between those domains. And we all know that the interconnecting gateway typically requires,
a lot of complex operation, it leads to some reliability, etc., etc. And that was, let's say, how the IP protocol being used for, let's say, the last 40 years. People thought it's very old, we have a lot of legacy deployment, it's actually impossible to change this protocol. And that's basically what everyone believed until SRv6 and SRv6 microSID came into the industry. And with SRv6, what happened is that the IP protocol become programmable, become self-sufficient. You don't need any layers on top of IP. You don't need MPLS in the WAN in order to do traffic engineering. You don't need VXLAN in the data center to do overlay or multi-tenancy. You don't need GTB, etc., etc. So with just the IP protocol and relying only on the IP protocol, single data plane, single protocol stack, you can deliver all of those services. And being native in IP, you can outperform any layer. Adding patch on top of protocol, for sure, does not have to say scale as being native. And the idea here is very intuitive. How you use SRv6 in the IP protocol. The IPv6 destination address, which is 128-bit, basically is used as two parts. The first part, which is called the locator, and in the remaining bits of the IPv6 address, you have a set of the instructions. Those instructions can be traffic engineering, overlay, underlay, service chaining, or you name it. So basically, you can encode all of the instructions that in the past you used to have an MPLS label stack to encode them directly in the destination address of the IPv6 protocol. It's a technology that is fully standard, so every piece of the technology is already standard now from architecture, data plane, control plane, and operation. You have the list of the RFCs here on the slide, and it has a very rich ecosystem, both from vendor viewpoint, so you can see all of the major vendors already supporting SRv6, all of the merchant silicon from open source, stacks, etc., etc. Now, okay, how this technology enable some of the use cases? And today we're going to talk about two new use cases. One is the AI backend networking, where you have the GPUs that they need to communicate with each other. And the second part, which is the front-end DC, where you need to connect to this AI backend network. Before going on into the solution and how it is used, as explained also publicly by Microsoft, what are the key characteristics of this AI backend? Basically, you need to do LLM training, and this LLM training model has to be distributed across different GPUs. And each one of the GPUs has to do some computation, and after one iteration of computation, you need to synchronize. And we cannot go to the second iteration of computation until we are all synchronized. So there is a moment where all of the GPUs has to talk to each other. And what are the characteristics of the traffic that those GPUs send? It's burst traffic, so elephant flows, so big elephant flows, but they are, let's say, long-lasting. So when these GPUs have to talk to each other, basically they need to talk for a long time, sometimes months even, and it's well known in advance because in AI you have a scheduler that says which GPU needs to talk to which other GPU. So if you put all of these characteristics together, elephant flows, long-lasting and well-known in advance, and having a scheduler, that is a perfect, let's say, characteristics of a traffic engineering use case. And this how SRv6 as a traffic engineering technology inside IP can solve this problem. So it gives you a set of, it allows you to enumerate the set of passes that you have in the network, and for each GPU to GPU communication, you can assign a given pass to it. And what is very interesting here, and where you see a lot of, let's say, talks like last year in 2025, there was at least 5 public presentations from Microsoft on the use of SRv6 in the AI backend. You can find them already on the internet. Basically, what is key here is being a standard and open vendor agnostic technology. This is not something proprietary that you need to get it from a vendor X or vendor Y. It's the same technology supported across all of the different vendors. So let's see how it works already, or with one example. What you see here is a factory topology, the closed fabric that we all know, spine and leaf. In some operators, they call it tier 0 and tier 1, where you have your GPUs via the NIC connected to this fabric. The first thing that you need to do is to assign each one of these devices an SRv6 identifier. In the terminology of SRv6, this is called allocator. So you take a /32-bit IPv6 prefix, you assign each node allocator or identifier from this prefix, as you can see in below here. So every node has an identifier. Once you have this, you have the topology of the fabric, and you have the identifier of each node. You export this to your controller, and the controller is going to compute for each GPU to GPU communication an SRv6 path. For example, here from NIC A to NIC B, when they need to communicate, they use that path encoded in that single IPv6 destination address. And it's actually very straightforward. You can even read it. This destination address says, go to node 1 in tier 0, and then from node 1 at tier 0, go to node 1 at tier 1, and then go to node 255 at tier 0, and from there you go to NIC B. So your steering of the traffic is very deterministic. You don't rely on ECMP that 2 flows will hash on the same path and cause a collision. Then, at some point, there is a congestion, maybe there is a link failure, and you need to change that path. You leverage the well-known techniques that you have in the AI backend to bring the congestion notification to the source. It can be bucket trimming. This is what almost everyone is talking about now in the AI backend. Or, let's say, any ECN notification. Once you have this, you have a pre-computed path, and you can change the destination or the encapsulation of the packet, and the packet takes a completely different path from the congested one. So basically, you can really place your elephant big flows of the GPU to GPU communication inside the fabric, avoiding any kind of congestion. This is something also that has been submitted as a draft at IETF with co-authors from the industry, both vendors and also operator. And in this, it highlights the key benefits of using SRv6 in the AI backend. And one of the key here is that obviously the optimal load balancing, but also being a standard open solution. Then this is the AI backend. So when you build this AI backend, you need a front end in order to connect to the hosts. So how was the legacy architecture of those networks? This is what everyone used to do. You do VXLAN inside the data center. You do MPLS in the WAN, and then you need a stitching gateways to connect those domains to translate the encapsulation from VXLAN to MPLS and vice versa. This is something also that has been explained by one of the operator, Nebius, in a public presentation also that you can find it online, and I'll leave you the link here. So what are the limitations of such architecture? First, if you look at the VXLAN, I don't have any traffic engineering capabilities again. And here the traffic engineering capabilities doesn't necessarily mean that you need to do the traffic engineering inside the data center, but your traffic engineering policies it starts from the center. So the traffic that leaves the host in the data center need to go through a traffic engineered path in the WAN. The only way to do it right now at VXLAN is at the DCI. You try to map the VXLAN into a traffic engineering policy. But then you go into MPLS. If I need to have a unified architecture, I need to bring MPLS in the data center, but there is no MPLS in the data center at all. Not even the hardware of the data center support MPLS. So you will always require this stitching between the domain. And if you want to do also any kind of service chaining, it gets more complex because assume that the traffic coming to you, and in many of the cases is coming from the internet and has to go through a firewall. So now you need to take the traffic all the way to the firewall and then from the firewall to the host. But it's not a single firewall, you have a cluster of firewalls. So you need to build a mesh of tunnels between the host and the firewall that doesn't scale. So what is the solution for this? As explained by Nebius at the MPLS and SRv6 World Congress in Paris this year. Basically, is to replace the VXLAN in the data center and the MPLS SR in the WAN with a single unified protocol stack across the two domains. And now you can have a fully unified design with one single protocol stack in the two domains. No need for VXLAN or DCI staging at the DCI. But what is very key here is that something that there is not at least a straightforward way to do it in VXLAN is to be able to do the service chaining or insertion of those services in the policies. And for sure, in the WAN, you get native TE. There is also another IETF draft, sorry, the title is not correct, but there is the IETF draft SRv6 end-to-end in DC, front-end and WAN, and basically here also it explained that design, and it's a draft by Cisco and Nebius as an operator. Then what else that you can do here? There is still much more that you can do with SRv6. For example, when Microsoft talked about this largest AI data center, we all understand that there is a limitation in power. So basically, you cannot fit all of the GPUs in one single data center, basically because you don't have enough power to do this. So everyone is talking about having a DCI network and AI WAN in order to connect those different DCs. And in those DCI/AI WAN network, traffic engineering is crucial. Why? Because you don't have the same resources as inside the data center, but also the latency here in the DCI and the WAN matters much more. So to summarize the requirements for this AI elephant flows traffic, you need traffic engineering. And in those DCI network, you have IP. And if you do the summation of the sum of IP plus traffic engineering, this is exactly what SRv6 provide you. Thank you. And in order to stay or to learn more about the latest, let's say, use cases on SRv6, there is a website of segment-routing.net, and there is also a book on SRv6 if you are interested to read it. Thank you.
Thank you so much, Ahmed. Any questions? Any feedback?
There is one.
My name is Natalie Treneman, M6. Interesting presentation, thank you very much.
Thank you.
I learned a few things, it's always good. I have a question about the IPv6 address segmentation that you did. You started with the /32, right, for the domain, and then broke it up in /48.
This one, or?
Yeah. in your examples, can the /48 also be like /56 or /64?
Well, architecturally, there is no, let's say, there is no limitation on how you split the format. There is different format. This, what you see here, is typically referred to as format 3216, where you have 32 for the block, and each node gets 16. There is, you can have other formats as well, but it will also depend on the vendor if they support such format or not. But architecturally, there is no limitation.
Okay, thank you so much.
Thank you.
Any more questions? If not, thank you so much, Ahmed. Thank you. Okay, we still have 4 minutes for the coffee break. Do anyone have any comments, any feedback, any questions, anything? Okay, I think people need coffee to wake up. Okay, so we will have 30-minute coffee break. The coffee will be served outside, and we will come back at 11, please. Thank you so much. And still use the time to socialize and ask questions.
Thank you for joining us, Bülent. Hello. Welcome to the second part of our today's program. This is now about IXPs. And yeah, let's go right away to our first presenter. We will welcome Amreesh on stage. He is from ISOC, and he will tell us a lot about the status about the internet exchanges in the region. And I saw that presentation about Africa before, so I'm very curious to see it about Middle East now.
Thank you, Marco. Good morning, everyone. It's a pleasure for me to be here again. I'm actually presenting those slides on behalf of my colleague, Hanna, who couldn't come, unfortunately. And our colleagues here miss him dearly. I hope to see him again soon. The idea is actually to give you a round of status on IXPs in the region, so more specifically in the MENOG region. So let's dive in. So, all right, so there are 14 countries in this region. There are 2 countries currently without an IXP. It is Yemen and Syria. But the other countries from Bahrain, Iran, Iraq, Jordan, Saudi Arabia, Kuwait, Lebanon, Oman, Palestine, Qatar, Turkey, and UAE, they all have at least one IXP. And we will look at how things evolved over time, and also the domestic network coverage, which is a metric that we are tracking at the Internet Society. So at the Internet Society, we have a tool called the Pulse Internet Exchange Point Tracker. So if you have a chance, go to pulse.internetsociety.org, and then there you will see an IXP tracker. You can go on this on your country of choice, and then you can see the different IXPs in this country. So you have the country view, and then you have the IXP view. We are actually tracking the number of members over time, and also growth in terms of capacity. And one nice metric that I would say is what we call domestic network coverage. So what do we understand by domestic network coverage? These are not only the active ASNs in the country that are peering at the IXPs, but they're also like the customers of those ASNs that are benefiting, that their upstream is actually connecting to the IXP, and therefore we have a coverage metric. So our data is coming mostly from peering DB. So whatever data you find on the IXP tracker, it is coming from peering DB. So if people are maintaining their records on peering DB, then you will have accurate information. But if not, you might see some disparities. So one way we're actually encouraging people to update their information on peering DB, because that is important. So we have seen that overall the number of IXPs in the region have been relatively stable. We have seen pocket of growth. Oman, Qatar, and Saudi Arabia stand out for increasing number of members and also adding capacity. And we have seen new IXPs in Iraq, Iran, and Oman. And this is probably thanks to the political and regulatory support that they have been giving. Then you can see some amount of development in those places. We have also seen quite little change in the number of members and capacity in countries such as Bahrain, Iraq, Jordan, Kuwait, and some amount of development in Turkey and Jordan. So this is what I was telling about, the domestic network coverage. You could see that some countries are quite well covered: Qatar, Palestine, Kuwait, 80%, 82%. So this is great. It means that a large amount of the networks in the country, so most likely eyeball networks, can now have direct access, direct or indirect access to the peering fabric in the country. And as you know, the more participants we have in the peering fabric, it attracts CDNs and therefore can help improve local peering and local interconnectivity between countries, and also help reducing latency to content. So we have seen when there is a strong peering and interconnection ecosystem, you will attract CDNs and other big players for them to come and serve their content locally. Now we look at capacity as well, and also the capacity of the country capacity in terms of transit. So we are getting this total capacity from telegeography, which provides data on the international connectivity and capacity. And what we are looking here is like, what is the IXP capacity? What is the ratio of IXP capacity over the total country capacity? So we see that some of the countries where we have high IXP penetration have actually little traffic going through the IXPs. So which reflects that, okay, there might be some amount of work to be done in this case. So there are IXPs in these countries, but potentially not enough peering happening, and not enough, potentially not enough traffic exchange happening, even if there are some IXPs. Now let's look at a country-by-country analysis. This is Bahrain. Bahrain has has one IXP and has 79% of all the members, all the active networks in the country which are connected. So there are 19 ASNs active in Bahrain, and 79% are actually are covered by the IXP. At the Internet Society, we also track what we call locally cached content. So we have a measurement campaign that we run. We take the top 1,000 websites that are the most visited in a country, and then we try to determine where they are located. For Bahrain, I haven't put the data here, but it's around 73% of content, the most popular content, are actually located in the country, and are served from the country. So it gives you some indication. So here we have good coverage, and we have also more or less also good amount of locally cached content. This is a little bit different from, so this is Iran. Iran has 589 active networks, and interestingly, only 5% of those networks are directly or indirectly connected to that IXP. I do not personally know the situation in Iran, so I wouldn't be able to explain why that's the case, but perhaps you have more insights. I would be happy to discuss with you on why we are seeing that amount of that low level of network coverage. The percentage of locally cached content is 50%. So Iran is an interesting case because we know that they are under embargo, so there are big players like Amazon, Cloudflare, and the others are not present over there. But what we have seen is that there are a lot of home cloud providers that are actually providing hosting services, and 50% of the most popular content in Iran is actually hosted locally. So moving on, Iraq has 152 networks, 2 IXPs, and 45% of network coverage. Jordan has 1 IXP, 50 active networks, and 72% of network coverage. This is Kuwait, 1 IXP, 71 active networks, and 82% of coverage. Lebanon, 2 IXPs, 145 active networks, and 39% of network coverage. And we can just move on and on. This is quite interesting for Palestine, 88% of network coverage. The slides will be available, or if you're interested to have a look at your own country, I would encourage you to go and have a look at the IXP tracker where we provide this information. So let's dive into what are the success factors of this and what has been helping to make the ecosystem thriving in some cases. So I would say strong government and regulatory support was key. So for example, you have here in the UAE, when the data center market was liberalized, and the hosting policies also, for example, with UAE-IX, it helped attract more than 100 networks, and those type of policies is actually encouraging more participation and building a stronger ecosystem. In Saudi Arabia, for example, we have seen the national peering increase with the policies put in place when you have Jeddah-IX or Riyadh-IX coming into the picture and helping to have a more connected ecosystem. We must say that, okay, things such as having neutral, carrier-neutral data centers, we talked about that yesterday, could help eventually, and this is what we should be aiming for, especially in this region as well. We have seen success. The carrier-neutral data centers have been a success factor in other regions of the world. An example would be in South Africa, for example. NAP Africa is operating a carrier-neutral data center and has been a catalyst in attracting many networks and creating something which is quite robust. But the challenges still exist, which are regulatory hurdles and political instability in some regions, unfortunately, like Yemen. And then what is also important is also the technical expertise, and that's why we have events like MENOG, where we can build a resilient community. So not only we need to build a resilient infrastructure, but we also need to build a resilient community by networking, by training, and other things that we invest into. So the key findings is that based on the trends that the region is moving in the right direction, we are seeing more progress, even if it is uneven. We would like to see more support, potentially from the regulators, and also for, especially when operators are state-controlled, it is usually difficult to actually break those barriers, but with more awareness and with more having a more liberal mindset, we are able to create positive change and possibly increase internet resilience by increasing the number of people that participate in the local fabric, such as internet exchange points or having, home-bred data centers and cloud providers, etc. So that's it in terms of overview of the situation in the region. So I would invite you again to go and see either the IXP tracker on the Pulse Internet Society website, or you have also the country reports, which is quite useful because it gives you an overview of the situation in your country, because we provide quite a number of health metrics, from internet penetration to the network coverage, speed, performance, whether you're doing DNSSEC validation. So this gives you a good overview of the internet ecosystem in the country. And the IXP tracker, as I mentioned, provide quite some useful information on IXPs generally. You might find some disparities based on how accurate the data is, again, because we are using PeeringDB as a source of information. We are actually actively working on finding other sources like IXPDB, peering looking glasses. The idea is actually to put together different sources so that we have a better database for, with more accurate information. So with this, I would like to thank you for your attention and happy to take any questions. Mic is off.
Okay. Thank you, Amreesh, for the presentation.
No, your mic is still off.
Thank you for the presentation. Sarah Lemin from Packet Clearing House. I have one question and two comments.
Sure.
Okay. The first question about the slides that you're presenting about the domestic connection in the exchange point. If I may ask, what are the methodology you have used to measure this, like the peering between each other, between these networks, or the peering with the route server, or how did you measure this?
Sure. So, hello?
Oh, I need to close.
Is it still? Okay. Hello, hello, hello. So yes, first of all, we know from our allocations and from the routing table how many active networks we have in a country, right? Then from PeeringDB, we have the number of, we get a list of peers from different IXPs. So using that, we can actually do a quick ratio of the number of peers in the country, so which are local, and therefore we can do a ratio of how many active networks are there that are peering, right? And then we can aggregate that over the country. But we are going one step further. We are looking at who are the customers of those peers.
Okay.
Then we can have like, because then we can know what are the networks that are also reachable.
Okay.
Yes.
Thank you. Okay, the two comments. First one, I think Iran has more than one internet exchange point. They have 3. The biggest one is Tehran.
Okay.
They have Shiraz and Tabriz. Maybe those are like a smaller. And the second comment that maybe you can consider using the IXP directory for PCH, because we are now doing a project to enhance information and validate all the IXP information on it.
Yeah, definitely PCH is high on our list to use as information. As I was mentioning, we have a project where we're going to merge data from PCH, PeeringDB, route views, and looking glasses. Looking glasses is great because we have live data from many IXPs around the world, and hopefully that database should give a more complete picture of the situation. Okay. Yeah.
Thank you.
Hello, Bernd from DKIX, but speaking for myself here. Thanks, Amreesh, for this topic. We share the passion and caring about this idea. Can you bring the slide, or UAE with 44 is anyway up here, because you said 44% of UAE is on the exchange. So what I wonder or would like to ask, assuming or knowing that the both operators do and END are on their internet exchanges, and they are more or less D2 licensed operators to connect each and every ASN within UAE, my expectation would have been to see 100% here. So why do we have 44 and not 100? Can you elaborate on this?
That's a good observation. So as I said, what we are doing, we are taking the direct peers at those different IXPs, and then we are going one level down and taking their customers. So we are not taking customers of customers. We are not going down the chain completely. We're taking like the first level customers. So perhaps our methodology can be improved here so this is good feedback, because then we can go back to the drawing board and see whether UAE needs to have like a better coverage based on, yeah.
Let's have a talk in the next months and years about this. Thank you.
Okay.
I was going to make similar comments. The numbers don't make sense to me. I'm Samad Dosari, Saudi Internet Exchange.
Okay.
We had us set a better number, I guess, 81, but we pride ourselves at 97% coverage. And I didn't understand the methodology that you talked about. If it was the case that you don't take customers of customers, numbers should be also very different than 80%. So it would be great if you could send maybe the methodology that you take.
We can do that, and normally we publish it on the website. But
it's not on the. I already checked. It's not on the website.
Okay.
Yeah.
Yes, I can definitely share with you how we are doing that calculation.
Yeah. So that's then I have another question or maybe comment. Has there been any analysis when you're looking at IXPs, which ones that you categorize? Like typically you have the commercial IXPs, you have the neutral IXPs, and then you have the operator managed operated IXPs. Have you kind of done that analysis?
No, we are right now just taking data almost blindly from peering DB. Obviously, we are doing a bit of sanitization. IXPs where you have only 2 members, we don't call them IXPs, so we don't even consider them on the platform. So yeah, we run some amount of sanitization. So, but the thing is, we are encouraging people also to keep their data up to date on peering DB. If that's not up to date, you won't see that here. We had a case, for example, I presented this in India, where they saw a quite low level, or even the number of IXPs were not tallying. So in India, there is NIXI, and they haven't put any of their information on peering DB. And we couldn't actually, for us, there is no other way to actually get a global data set of IXPs if it's not peering DB.
Well, no, you could basically look into each exchange, and then from there understand who owns the exchange, right? And then from there, is this entity a commercial entity? Is it an association? Is it a data center? Is it a neutral data center? What, it's a lot of work.
It's a lot of work. Yes, it's a lot of work. But that's a great suggestion, and this is something that we need to be doing in the future. Yeah.
Thank you.
Hi, I was from Iraq IXP.
Iraq?
Yes, okay. Iraq. So the thing is, I have only one comment, that there is only one IXP licensed to work in Iraq. And during your presentation, you said this is 2.
Yes.
So just asking, where it says it's 2.
So
thank you.
Did you check on peering DB? What information do we have? Did you see 1 or 2 there?
Yeah, it's only 1.
There's only 1?
Only 1, Iraq IXP. Thank you.
I will double check that. Thank you.
Hi, Amreesh. Nishal Gobardhan, Packet Clearinghouse, but also speaking as an IX operator and an amateur researcher, because I'm not really smart enough to do the work that you do. But I like data, as I've told you in an earlier comment, and I think that one thing is evident, that the source of truth that you're using needs work.
Yep.
And I think for the researchers that are listening, like I like knowing what the margin of error is. So I quickly looked up, and one of the exchange points that I'm responsible for, we have more than 250 odd peers, so the margin of error there would be a useful number. So for your benefit and for anyone else that's listening and for posterity, the margin of error between what's published in PeeringDB and what I know to be canonical, because I'm the exchange operator, was 15%. I've looked at other exchanges very quickly while you were talking, and in some that's as high as 27%. And that's a significant number for research purposes. So I don't know if that's helpful to you, but like I say, for any other amateur researcher like me, it's good knowing that error rate.
Yeah, we are looking at ways to improve this. Definitely, this is just like a first step into understanding peering data, and definitely, unfortunately, we are a little bit unhappy with PeeringDB data, even if it is something that we are encouraging everyone to use. But we are going to hopefully find ways to make this better and talk to you and to make this better. Thank you.
Thank you, Amreesh. Big applause. So, I mean, maybe one thing came out here very clear. All this is super interesting, but it needs data. So to the whole community and as exchange providers, we definitely see that, and this was also your comment, we see that people don't put that accurate data on PeeringDB. So this is to all, everybody in the community benefits if we have accurate data on PeeringDB. I mean, and the percentage, especially here in this region, is dramatically high in some points, and sometimes it's really done by the IXP operators for the peers that it's somehow accurate, because as said, it's not only for the statistics, it's also for your peering itself and for the quality of peering. So if there are any operators in here or other guys, make sure you have accurate data. So that's enough from me. I want to now from the statistics, going back to real life, and I want to welcome on stage Fadi, who will tell us about the Lebanon exchange, or the development of exchanges in Lebanon, to be more precise. Thank you.
Okay. Good morning. Thank you for having me here. My name is Fadi Khoneisser. Initially I'm a telecom engineer. In a previous life, I was the managing director of one of the largest DSPs in Lebanon. Now I'm the director for development and growth in Berytech. Berytech is a business support organization helping entrepreneurs and SMEs to develop and grow. So if you're wondering why a business support organization is managing an IX, just wait for a couple of minutes and you'll get the answer. So I believe everybody is aware of what an IX is, so I won't delve into this slide quickly, but just we know that the IX will enable ISPs and networks to exchange traffic locally, and they will support them in reducing cost, lower latency, and increase in resilience. So how did Beirut-IX come to life? In 2006, there was a war, yes, a war in Lebanon. This is normal. And just after this war, the American government decided to support Lebanon in a way or another. So they encouraged American companies to come up with some project ideas. So there was something that was formed that was called Partnership for Lebanon. And it was, we had companies like Intel, Cisco, Microsoft, and others who gathered together and came to the idea that we will develop some things in Lebanon. And one of the ideas was to have an IX. So they came to Lebanon and they contacted the ISPs that were available there. At this time, there were 8 ISPs that are considered as the founding members for Beirut-IX. And the idea was at that time to have an IX that would benefit Lebanon and reduce cost, international bandwidth cost, and serve as a local IXP peering. When Cisco came, they donated a switch, and we had support also from, at that time, PCH, the Professional Computer Association in Lebanon, and other local entities. So initially, the 8 ISPs were connected to the IX, and the idea was to find a neutral place where to put the devices. And since all ISPs love each other, they couldn't agree among themselves where to put this, until someone came with the brilliant idea to have it in a neutral location, and they decided to go for Berytech. Berytech, as I said, is a business support organization. It is located in the campus of the St. Joseph University in Lebanon, which is one of the oldest universities. So Berytech provided a room. It was transformed into a data center, so they put their racks and they provided power, etc. And this is how the IX was born. It came to life in December 2007 with 8 founding members, and they have created some kind of a small NOC. So they were electing 3 members to run the IX technically. And there were no membership fee, just they were paying the co-location fees. And it remained like this between 2007 until 2015. They were just exchanging local traffic. And local content in Lebanon is really very low. So we are talking about hundreds of megabits only during a period between 2007 and 2015. In 2015, the major development came with when Google provided its cached server. And this is where the IX started to grow. Just after having Google, we received also servers from Akamai, and later the node from Cloudflare. The problem here came that there was no governance for this. So the 8 founding members thought that they had veto powers. So they started selecting the ISPs who would be allowed to join the IX, because they have divided the ISPs in Lebanon between legal ISPs and illegal ISPs. They thought that they were the legal ones because they had a license from the Ministry of Telecom, and they are distributing, their local loop is licensed under licensed data service providers, while the 100 other ISPs are smaller ones, not all smaller ones, but they have license from the Ministry of Telecom for international capacity, but their local loop is not licensed. So they are installing Wi-Fi, cables from building to another, illegal fiber. So the 8 founding members decided that they had this voting power, and they started putting rules on the smallest ISP. For example, one ISP wanted capacity over Google, for example. They decided that we will give you only 35% of your international capacity, because for them, 35% was that ratio between international capacity and cached traffic on Google. If they wanted more than 35%, they considered them as illegal, so they didn't provide them with this. So this led to several challenges where we did not have a very high number of members. Traffic did not grow very quickly. Number of members went from 8 to 15, 16, but it could have easily gone to 100. And the other problem was that we were only relying on microwave links. The microwave links are limited in terms of capacity. You cannot put several gigabits in the same direction and since you don't have several frequencies to use. So this was the first limitation. Fiber took time before arriving to the IX. Now it is available. So this is the first technical limitation. The second limitation was more on a financial part. the CDNs that are available in the IX, they are not participating in the costs of the IX. So the IX and its members have to provide the international capacity, cover for its costs, and cover for all other costs like management fees and co-location fees, power, etc. So, and this is a model that is very, very difficult to manage because it is really dependent on the volume of traffic and the amount of international capacity. So if a member upgrades during a month, price might go slightly down, but if a member downgrades or we need more additional international capacity, prices will increase. So we are not able to provide a fixed price. Members are not paying per port, they are paying per capacity they are using, and the price per megabit is varying from 1 month to another. So for example, last year in 2024, prices went down from around $9 per megabit to reach a bottom of $6.5 per megabit. So it was very good. It was going down. This year we have the other way around. Prices are going up. So we went from 6.5, we are around $8 per megabit nowadays because of this fluctuation. This is really not easy to manage, but this is how things are going for the time being. We had other limitations also coming from the fact that we were not able at that so far to have the incumbent, which is the largest operator in Lebanon, and the 2 mobile operators to join the IX. We'll talk about this later on. The other problems that we had is that we started having competitions from our own members. So people in Lebanon, since the local content is very low, people are relying on the CDNs to have additional capacity and reduce their international bandwidth. So we can see that all ISPs are trying to get access to CDNs as much as they can. So we have servers from Facebook, Google, Akamai, Meta, I don't know, I say Facebook and Meta is the same. So we have these several servers that are deployed everywhere in the country, and there is a competition between the ISPs of who will be able to get more smaller ISPs into their they are not IXPs. There are just ISPs selling capacity on the CDNs. So this is really a problem for us. And on top of all this, we have the regulatory environment that is not really helping. So we had a TRA that was operating between 2007 and 2012. The mandate of the board of the TRA ended in 2012. They were not replaced. So between 2012 and 2025, the TRA was operating without a board. So practically they were not doing anything. In Lebanon, the Ministry of Telecom has a monopoly over everything. So they control the international capacity, they control the local loop, everything related to copper and fiber is controlled by the Ministry of Telecom. So international capacity, voice, and local loop access, everything is under this monopoly. And all prices are set by decrees that are issued by the President of the Republic and the Council, the government. In 2017, bizarrely, I don't know how this happened, they issued a price decree and they gave 40% discount for IXPs on the international capacity and 30% discount on the local loop. So we said, yes, this is a great opportunity for us. Let's use it. So we sent letters to the Ministry of Telecom requesting that let's apply these discounts on the IXP for international capacity, on the local and the members on the local loop to allow them to reach the IX. So letter after letter, we didn't get any response. So we went to the Ministry of Telecom and we told them, why aren't we able to get this discount? The first answer we got is that you are an IXP, why do you need international capacity? So we explained to them that the international capacity is needed to fill the cache. Okay, this was the first point. The second point, they told us, okay, you are an IXP, but at the Ministry of Telecom, we don't know what an IXP is. We have a definition for ISP, but we don't have a definition for an IXP. And until today, there is no definition in the Ministry of Telecom about what an IXP is. And in 2023, they cancelled all the discounts that were given to the IX. So everyone is happy. So in the meantime, we were trying to get the incumbent to join the IX. The incumbent is Ogero, which is the operating arm of the Ministry of Telecom. So we told them, please join the IX. They told us, yes, it's very good, we want to join the IX, but the IX is not a legal entity. Okay, Beirut-IX is just a name, it's not a legal entity, it's not a commercial entity, it's nothing. So we have worked on this level, and on January 10, 2019, we received a memo from the Ministry of Interior creating an association, a not-for-profit association called Leb-IX. And the purpose of Leb-IX is to operate the IXP in Lebanon. It will be operated in a non-for-profit way, neutral, open and inclusive, and open peering policy. So now we have this legal entity that was created in 2019, and it is there. So we have now something that is legal. Unfortunately, because nothing is easy in Lebanon, in 2019, we had the financial collapse, the political collapse. It was followed by the COVID crisis. It was followed by the explosion in the Beirut port that destroyed large parts of the capital. It was followed by the war in 2024. So during all this period from 2019 to beginning of 2025, the IXP, the Leb-IX, was dormant. So there was nothing that changed in the status of this legal entity. In 2024, things started to move slightly. We got a grant from the ISOC Foundation, and we used this grant. When I'm saying we, it was Berytech, who is managing the IX, got the grant from the ISOC Foundation, and we used this grant to support the infrastructure of the IX. So we replaced batteries, we replaced ACs, we received additional servers to install tools and IXP Manager, etc. And in 2025, the Lebanon chapter of the ISOC in Lebanon received another grant from the ISOC Foundation, and they decided to use it to revive Leb-IX. So it is currently being deployed on several fronts. The first one is the legal part. So all legal papers needed to be updated because since 2019, nothing was done. So they updated all legal papers and they submitted everything to the Ministry of Interior because non-for-profit organization, the ministry that oversees their operation is the Ministry of Telecom. So all legal papers have now been updated. A new board for Leb-IX has been elected at the beginning of the year, and we are working now on the governance model, the technical design, the marketing and commercial plans. So we are recruiting experts to support us in these fields. So currently the IX has 25 members. We are adding members roughly every month, 1 or 2 per month. We are mainly using now fiber, but microwave links are still there. Some ISPs are using them primarily to get to the IX, but others are using them as redundant. Our international connectivity is going through fiber, but we have kept some microwave links for redundancy purposes. Practically, the transition from Beirut-IX to Leb-IX has started slowly. We are asking our members to just go on a website and register that they are now member in Leb-IX. We have currently CDNs from Akamai, from Cloudflare. We are hosting the Lebanon domain name registry, the .lb. It is registered at the IX. We have platforms from PCH, from VeriSign, and we have some tools from RIPE, NCC, KRoute, ODNX, AuthenticateNX, and the Atlas probes. We need to check the Atlas probes. It's not working. Okay. So our aim is to have a neutral IX, which is the case now since the eight founding members are not involved anymore in the daily operation. They don't have this veto rights anymore, so we are able to operate the IXP in a neutral way. It is operating definitely in a non-profit way, so all costs are being divided upon all members depending on the capacity used by each member. So it is a proportion on all costs, international capacity, you have the co-location fees, the administrative fees, the management fees. All these costs are divided proportionally among the members depending on the capacity that they are using. So the aim is really to have this IX as the central internet hub for Lebanon. We are in direct contact nowadays. Since the beginning of 2025, some major changes occurred in Lebanon. We have now a president of the republic. We have a new government, functioning government, which is still... we have a new minister of telecom, and we have a new TRA, which is something that has really been a great evolution since everything was stopping since 2012. So we went to the new government, we went to the new Ministry of Telecom, we went to the new TRA, we went to the new Director General of the incumbent, and we have, again, explained what the IXP is, what's the role of the IXP in the local economy, and what is the purpose of having a neutral, not-for-profit organization. We are not starting from scratch, but there is a learning curve for all these new institutions. TRA board is now 2 or 3 months, so they are really new. They have a lot of things on their plate. So the IX might not be on top of their priorities, but they are willing to cooperate with us. Same for the Ministry of Telecom. The path is long, but we are definitely getting there. We have been in contact with the mobile operators. The mobile operators are today owned by the Ministry of Telecom. They are now willing to join the IX. How long will it take for them to join the IX? We are not sure about it, but this week we had meetings with one of the CEOs of one of the mobile operators, and now he's willing to cooperate. Again, with the TRA, we met them also 2 weeks ago. They told us, let's go for it. So we have prepared a letter. It will be sent to the TRA either probably beginning of next week. So things are moving slowly at the rhythm of Lebanon. We hope that we will not have a new war, so new setbacks, but we are on the right track. And what we need is a continuous support from the regulatory authorities. We need to have more ISPs and CDNs joining us, and we are working on this. And we have a call to all donors and technical partners, a lot of them here. We are getting support from the ISOC Foundation, we are getting support from RIPE, NCC, from many experts here in the room. So let's keep it up. We have a great path in front of us, many things to be added to the IX, and we hope to get there very soon. Thank you. Any questions?
Thank you very much. My name is Ahmed. I'm based in Dubai. Thanks for your presentation to get the big history of internet exchange in Lebanon. My question is, what is the backup plan if current internet exchange gets banned or if there is any kind of disaster? Since Lebanon is not...
If we get no support?
Yes. What will means what is the backup plan if the current exchange get banned or get any kind of natural disaster, or what happen again in that place?
It has been alive since December 2007, so practically almost 20 years now. We have survived many wars and many ups and downs. One thing is sure is that the environment is very complicated there. But now we see that they are getting to the idea. They know now what an IX is. We still think that the incumbent might request to have the IX in their place. But we know in that case, it will not be a neutral IX. It will not be a non-for-profit IX. So this is really what we need in Lebanon. We have 120 ISPs, and we really need a neutral and non-for-profit IX. The idea is there. The idea is going around. The government is okay with it. The TRA is okay with it. We just need to put the plans into action and do it in rather quickly. If everything fails, I believe the incumbent will play this role. Unfortunately.
Hi again, Sarah from PCH. Thank you, Fadi, for presenting the journey for Leb-IX. Well done, guys. I have maybe a comment can be answered the question that Ahmed asked. Maybe could be the backup plan that now we have 25 members and we are meeting them. We are telling them that the IXP is important, the benefit that you are getting. So we need you to be our backup plan. If something happened for this exchange point, because we all know the benefit of it, so you will be our backup plan. Maybe one of the ISPs will say, okay, we will host it in our data center. Maybe someone will say like, okay, we will give you a backup data center or something like that. So it can be a backup plan, and it's also suggestion like use your members, let them trust you, let them see the benefit they are getting from you, because this is also benefits for, it provides benefits for them, and then they can be your main supporter, honestly. Not even the biggest sponsors, like they sponsor you, because,
One thing important is to note here. The ISPs are seeing the IX as a CDN provider. They are not really seeing the benefit of the local peering, even though the traffic is quite low. So we are working on this. But they see for the time being that the IX is another CDN provider. They can take their Akamai traffic or their, I don't know, they are the only ones who have Cloudflare in the country. But let's say their Akamai traffic, they can take their Akamai traffic from the IX, but they can take it also from several other ISPs who have Akamai nodes. The issue is that it's a question of price, because everything is legal in the IX. The international connectivity is legal. The local loop is legal. We are not accepting members that want to install their own illegal fiber, or they want to reach the IX over illegal microwave links using illegal frequencies. Other ISPs are getting any other ISP over illegal fiber and illegal microwave links, so they are not paying for the local loop. So our cost is always higher than the cost they are getting from other CDNs in the country, because everything is legal in the IX. And all other ISPs are not, I would say that are putting a blind eye on the local loop. So, but this also is going to change because the TRA, one of the priorities of the new government and the new TRA is to put an end to these illegal networks. How long will it take? 1 month, 1 year? We're not sure about this, but this definitely will change, and we're hopeful on this. Nishal.
Hi, Fadi. Nishal Govardhan, Packet Clearinghouse as well. So I also run exchange points, you know this, and I think that in the last few months, at least one network, global CDN has proven that they don't really like exchange points for reasons that don't really make sense to those of us that run exchange points. And I actually don't care about them because I don't use their services, but I know other people do. And I think that it's important for internet exchange points to understand that if the core of their, and I hate using the term business because I don't think that exchange points are businesses, with respect to those that have them. That's not my belief system. But if internet exchange points continue to believe, and perhaps if your community continues to believe that the function of an exchange is simply to be a conduit to a CDN, then you have a very limited lifespan up until the other big CDNs decide, well, we can do this cheaper via PNI or some other silly means, right? So I guess my question to you is, as a startup IX, and I feel your pain because I run community exchanges in multiple countries, what initiatives are you doing and how are you approaching, and perhaps you can provide some guidance to people here to say, what are you doing to reshape that thinking that the exchange is not just a conduit to a content delivery network? And perhaps if you have questions for people here that can help answer, what could be done to teach your community that an exchange is more than just, a next hop, a layer 2 to another CDN network, because that's certainly not the case for many other environments in the world. So are there national initiatives that you're driving through your grant, for example, to say, let's build domestic content, let's build domestic interconnection that's completely independent outside of, decisions that are made at global content level that are outside of our scope of influence?
Excellent point. And this is exactly what we are working on. We know that the Lebanese content is very low. We had, just for example, we had one member who had a server offering streaming for Lebanese TV stations. And the obvious place for him was to put this content in the IX. And once this IX, this server was installed in the IX, traffic reached several gigabits when there was, for example, a national event, a basketball event, a football game event. So we reached peaks of 15 gigabit per second over a period of 2 hours, for example. So these were very beneficial for the ISPs because they understood that having a local content being served from a local place is very beneficial for them. They were able to save 15 gigabits in international capacity over a duration of 2 hours. So the idea is coming to be more easy for them to understand what's the benefit of this. Now, all Lebanese newspapers don't have their content in Lebanon. They have it on Cloudflare or somewhere else. They don't, all TV stations have backup solutions outside Lebanon for their streaming, etc. It is, the idea now is, through the TRA, is to convince everybody to have more platforms available here. We know that there is a large data center in the country. It is managed by the incumbent, so some data related to the government is being put in this data center because it belongs to the government in a way or another. But we are looking for more local content to be able to have it here. We have the .lb, domain name registry for Lebanon, which is nothing in terms of traffic, but it is important traffic. If you see the total number of gigabit, it's nothing. But still, the idea is coming, and people are now understanding the importance of having an IX in the country. And we are going through the TRA because now they are new. They understand the idea, but we need to go quicker with them.
Yes, thank you, Fadi. And a big applause for him. Because you cannot appreciate enough the passion he is putting into this to make an exchange in Lebanon work, because it's not the easiest environment, and so it takes a lot of passion and a lot of energy to build that. So that's why this has to be really appreciated. And having said that, Nishal, you give so much content for a whole panel, by the way, just by asking a few questions. That's amazing. Also applause for the questions. Anyway, we're coming now. Yeah, think about it. So we're coming now to the last presentation for this IXP session, and well, it seems that no session can live without AI. So now we're coming to automation for NOC, and I want to ask Dade Aderemi on stage, please, for his presentation.
Good day, everyone. So my name is Dade Aderemi. I'm an independent consultant based here in Dubai, but in previous times I've worked at the RIPE NCC at the Amsterdam office. So it's quite good to see some of my old colleagues here. So today I'm just going to talk about AI, specifically the spectrum of tools that we have when it comes to network operations. So it's going to go through like the relatively primitive tools, the conversational tools, the ones that we know as chatbots, to the relatively sophisticated models, the ones that we call agents. So I'm going to start off with a scenario that I believe some, or if not all of us, has experienced at a particular point in time in our career. And that's the scenario of dealing with incidents. So let's say at a particular point in time at night, all of a sudden the alerts start coming in. Something is going wrong. You don't know exactly what it is. It could be an hijack, it could be a misconfiguration, it could be a cable cut, but basically something has gone wrong. So at that point in time, we usually go into like a fight mode, where we look up all of the monitoring tools that we have available to us, and also all of the adjacent tools that we use for debugging, things like this, so your WUIs, your RapidStat, and all of the above. And at this point in time, every second counts, because the longer the issue is unresolved, the greater the potential damage. And the problem at this point isn't really about the data. The data is there. You have your monitoring tools. The problem or the difficult part is actually being able to connect the dots and do it fast enough. And that's the question I started asking myself, like, okay, in such a particular scenario, could it be, can we use something like AI to actually make this much better? What if we have a way to get like an incident report, even before you open your laptop, with actionable items and a very, very digestible overview of what has happened? And like I said, it was at this point I started thinking, okay, is this a problem that AI can solve? Because having lived through some of these operational issues myself, and also having watched people actually go through it, and about the time when ChatGPT took the world by storm, I was like, okay, could it be a place to connect the dots? Because this looked like a system that has some form of ability to reason. It can summarize things, And on top of that, it can actually also like code. And as a software engineer, I got curious. Could I actually use this particular tool to make things like incident reports a bit more easier to manage? So the first thing I looked at is the chatbot. And this is basically the interface that most of us are familiar with. Like when you're using ChatGPT, it's basically a chatbot. You chat with it, and it gives you a response. But there are a couple of things with the chatbots. There are things it's good for, which we will see. But there are other parts that is a bit undesirable, or things that it's not good at. And there are parts that you really don't want happening when actually using chatbots. So the first thing is like the good part. It's a natural language interface where you can actually like talk to it, and it can talk to you back in natural language, and you can easily get access to information without having to memorize and remember some of the complex queries. It's also good for knowledge recall. It's actually good. So it's a good place to actually go to get explanation of concept. It's also good for summaries, but let's see. It's not moving forward. Okay. So, but there are a couple of things. The first one is no real-time information. So there's a small asterisk on this point, and that's because the current iteration of tools like this do have access to the internet, so you can actually do get some real-time information. But apart from that, you also have no access to domain-specific context. So a chatbot don't actually have access to your documentation, it doesn't have access to your policies, it doesn't have access to your topology, so it can't really use this as input when you ask it some questions, and it can't use that to help you. It also doesn't integrate with any of the networking tools that you use. It's really just a chatbot, and hence it can't really take actions, it can't enrich, it's basically just what it is. And last but not the least, it doesn't have autonomy. But the ugly things is that it hallucinates. And that's the fact that it can actually confidently make up stuff. It can tell you the wrong things, and this is something you don't really want in the context of network operations, because really bad things can happen. So example of such is this was a couple of years back where some lawyers were fined because they just took what they got from a chatbot, and yeah, unfortunately, the chatbot just made that up. So again, really bad things can happen. So the question is, right now we have like a brain that can reason, but there are a couple of drawbacks to it. It's disconnected from the external world, and it can't really take actions. So the question is, okay, what are the things that we can do to actually improve this situation? So the first thing is tool-aware chatbot. And the big idea behind this is that you give the chatbot access to function calls, and with this, the chatbot can then be able to actually take real actions. It can fetch real-life data, and then it can execute tasks on your behalf. And one of the standard way of providing the chatbot this capability is the model context protocol. So I started looking around, like, are there like networking related MCP tools that can be used? I found a couple. The first one I'd like to talk about is the MCP RipeStart. And this is basically an MCP server or a tool that allow the chatbot to actually have access to RipeStart API. And with this, it is possible to interact with the RipeStart API in natural language, and then you are actually able to fetch, what's it called, real up-to-date information. This project is managed or is maintained by someone called AJ Wolski, and it's here on GitHub. Okay, so yeah, currently it has about 22 tools. So as you can see, you have like things that allows you to get access to the looking glass. It can do routing status. It can get you routing history. Essentially, the tools that gives the chat bot like much more functionality. The next one is Whois MCP, and this is an MCP server tool. It's a tool that extends the ChatGPT with real-time information from the regional internet registry. And this is also there on GitHub, and this is a project that I created and I maintain. So let's see how these two tools kind of like change the way that we can use Chatbot. Yeah, I'd like to mention that it has currently 14 tools, and this covers all of the 5 regional registry. So the first example is basically asking the chatbot what are the ES sends in this particular ES set, and the response it gave, it correctly identified this as what it is. It is an autonomous system set. It was able to get it by Etna, but to be able to actually find the current ASNs included in this set, it just was able to just give me the query that I need to run. Unfortunately, okay, yeah, this is the query that I need to run. So it was able to help, but it's not as useful as I would want it to be. The same question, but this time around, asked with the Whois MCP connected to it, it was able to actually go ahead to actually do the query and then present me with the result. If you ask me, I believe this is much more useful compared to the initial response that I got that was just able to give me like a summary. And the nice thing about this is that you can also see the function call in mid, so you can actually see the trace and you can actually also confirm. So this shows an example of how we can move from just a chatbot where you can just like talk to a chatbot that can do something much more useful. So the next example is basically asking if what's the stability of a particular prefix over a particular period of time. And it says that it doesn't have access to real-time BGP routing data, and hence it can't really actually answer this question, really. So it just gave me an overview of like the places that I can go to actually get this data. If we ask the same question, but this time around we are using the MCP RipeStart, we can see that it was able to use some of the tools available, some of the function calls. It was able to use the get prefix routing consistency. It was able to look into the routing history. And then based on this, it was actually able to give me much more useful data, much more useful answer to the question that I asked. So this, again, shows like you can move from something that is a bit more static to something that is a bit more useful by making the chatbot tool aware. So at this point in time, we have a system that can be connected to the external world. It can do things, but it still lacks a bit of autonomy. And by this is the fact that when you use a chatbot, you have to invoke it. And that is not as flexible as we will want to be. So the next step is what we call, or what I call AgentOps. So that's basically moving beyond just the chatbot, right? So, and the whole idea of this is basically giving a bit of autonomy to the AI system. So basically, what are agents? A good example or a good illustration I've seen is to describe or to think of them as your traditional travel agent. Basically, where you tell them where you want to go, when you want to go, and your budget, and the travel agent goes off and tries to find you the best deal. They can come back to you to ask for feedback, and then you can respond, and they can do their job autonomously, and they will give you back the results. So agents, when it comes to AI, is basically similar to that. They are systems that combine basically 4 things: reasoning, tool, a feedback loop, and a defined goal. And they can then go ahead and be able to work on this. So there are 2 things I'd like to double click on this, and that's the first. The first thing is that they work based off a defined goal. And the second thing is that they can work without human intervention. So like I said earlier, with chatbots, you have to kind of talk to it, but with agents are a bit more versatile. So you can still chat with an agent, but an agent can be invoked based off event or alert. So that's one of the nice things with them. And why do we actually want agents? Because this also gives us a lot more capabilities. And this has led me to start working on something I call AgentOps. And the idea behind this is to create an agent specifically for network operations. And by this, so like I said, it's a prototype of an agent built specifically for network operations. It combines existing tools, so basically things like BGP Alerter for monitoring. More tools will be added to it. It combines this, and then it is built around the human-in-the-loop design by default. And human-in-the-loop is actually a very, very important bit when you're talking about AI systems, because at the fundamental levels, the AI system, the LLM that powers the current iteration of AI systems it's not deterministic, and you can't fully 100% trust it. And hence, you still need humans in the loop to actually grant it permissions to take actions. It's built in Rust, and most especially, it is open source. And this is also a work in progress. So I'm just going to give you a quick pick of the things that this can do for you. Well, maybe before that, a quick overview of the architecture. So this works by, like I said, you can invoke the agent not just by chat, but via external alert. It comes into the system. You have a configuration where you kind of tell the agent the kind of resources that you are interested in. And when the alert comes, it first checks, should I even act on this alert? Is it related to a prefix or an ASN that I'm interested in? If no, it ignores it. If yes, the agent kicks in. And depending on the things you've configured, it then uses the tools, and then it can then create an output. And basically, that's the general overview. So a scenario that I used for testing is basically a BGP hijack. So an ASN is announcing a prefix it's not authorized to announce. That's the simple case. So I have the configuration. Currently, this is working off the BGP alert configuration language. And in this particular case, I was able to trigger what would have been a BGP hijack. And I just want to show a quick feature of what you have here. Because at this point in time, when the alert came in, the agent was able to take the alert, it did its thing, and then it was able to give me a good summary of what's happening. So I was able to tell that a particular resource is being announced by a particular ESN, and that's not the expected origin for that particular resource. But more important is that it has been able to actually give me much more enriched information about this particular incident, in the sense that it was able to tell me that, okay, this particular hijack is actually related to an IP address that shouldn't even be in the routing table because it's a bogon. And this should never even appear live. It tells me the timeline, and it tells me the number of peers that have observed this. And it also gives immediate actions that I can take based on this particular event. So obviously, it told me to contact the offending organization that is responsible for that particular announcement. Apart from that, it also tells me that I also need to look into my configuration and make sure that I'm filtering out the things that are not even supposed to be ingested anyways. And then it told me that I also need to check for other prefixes like this, so that this kind of things shouldn't even happen. So this is one of the cool things about it, is because it doesn't just give you the summary of what's happening, it gives immediate action steps that you can take. And then it does a risk assessment of what just happened. But let's say you also have follow-up questions. You can also chat with the agent. So this is what I mentioned earlier on, that with an agent, it's a more versatile system. It can be invoked, it can be interacted with via chatting, but it could also be invoked via alerts and events. So in this particular case, I just thought, okay, I want the email address I need to contact, and then it was able to kind of easily give me the information that I need. So this is an example of how we can move from where we started up from just chatting with a chat interface to having a chat interface that has much more capability based on the fact that we have given it tools that it can use, to having a system that is much more autonomous, that can interact based on the event that comes into our network. And then before we even spend extra time, it can give us a very good overview. It can give us action points. It can give a risk assessment, and we can also interact with it. So the next question is, what comes next? So like I said, we've moved from a chatbot, a simple chatbot, to something that is much more sophisticated. I'm of the opinion that once agents are actually wired into the network operations, and they have much more access to operational data, a more capable class of automation becomes possible. Because we have this, it's basically, you can think of it like unleashing the power of the AI, and you do that by actually giving it data that it needs to work on. So what can the whole idea or the whole model of agents unlock? I've showed one, basically autonomous incident enrichment, but it can also do playbook execution. So this is where you have a defined set of workflow, and the agent by itself can reason based on a particular event, which particular playbook to execute. It can also, like I said, reason on your data, and then you also have the human in the loop automation. This is something that we always want. But apart from this, it can also do a lot of boring, you might call boring tasks, and this is also one of the places AI systems actually shine. So things like automatic ticket drafting, this can be delegated to the AI agent, or you could also have it to perform analysis based on your upstream, your peer behavior. Like I said, it depends on the amount of data that it can actually reason over. It can do event correlation across systems. It can do documentation extraction. Basically, the extent to what you can do with agent systems is basically limited to your imagination. So all of the things that I've talked about, including AgentOps itself, the MCP server, and all of these things are open source. So basically, anyone can basically look into this. The network operation is, like I said, is one of the domains that AI can really help. So what's next? Or how can people get involved? I personally don't run a network, but this is basically a call for invitation for network operators to basically contribute real-world scenarios, like real-life events that you will be interested in and the kind of things that you will want the AI to do. Basically, things like real-life incidents, issues that you've had, daily pain points, and these are the kind of things that can be that can serve as feedback as the agent itself gets developed further. So that's how you can get access to the AgentOps for now, and that's the Slack workspace. Feel free to join, and then if you have any questions, you can, or if you have any future requests, this is a nice place to drop them. Yeah, thank you very much for the time.
Can I have a question, Mr. Marco? All right. Hi, Jad Al-Shamra, NCC. Can you please go back to the slide where it showed the medium severity ticket, the one where the hijack is? The first one, yeah, this one. So, question, is this a mock-up or this is based on actual hijack that happened and it triggered this alert?
It's not a mock-up, but it's based on, because like I said, there's an HTTP server that you can use to craft an alert. So this was actually, this didn't happen in real life. This was an alert that I crafted myself to simulate an hijack scenario.
Okay, so not based on something that is real.
No.
All right, because the comment that I was going to say is that one of the, I'm not an AI expert myself, but I know that people are worried about it because, as you said, even the chatbots today, they might give you confidently wrong information. For example, here when it said this /24, it conflicts and the expected origin is the AS333, so that raised an alert because that's wrong. So we don't announce this. We've never announced that. So maybe one of the comments or contributions or whatever is that whatever data that you show, something like this that might drive people or network operators down a troubleshooting path or a rabbit hole, because they can be equally the same, maybe you should be able to point to the origin of this information to double check or not. Because if that was something, a real life ticket, and I see that, oh, it should have been originated by this AS, while this might not be the case, yeah, then things get very, very messy when you start doing troubleshooting. I'm also wondering if this accounts for stuff like, let's say, anycast traffic, or when, for DDoS reasons, another AS would be announcing these IP addresses. Is this tool smart enough to differentiate these types of traffic? And not flag it as, ooh, there's an issue.
At this point, no, because it's at the early development stage, and this is where like people in the community are actually welcome to actually contribute their criticism and feedback and future requests to like things that they want to see. So currently this was just a quick and nasty way to create an alert that can trigger the agent. So it's not a real life scenario, so it's not something that happened in real life, right? So this was more of like a trigger, but in terms of like being able to work in terms of the Anycast or DDoS stuff, I believe in theory that's something that is possible, because at the end of the day, it's reasoning over the alerts that it has. It's reasoning over the inputs that it has.
Okay.
So, and not just that, it's also, you can also guide the agent. You can give it, you can give it knowledge. So it's guided by the knowledge that you as a human has, and it can use that to also guide its reasoning. So at this point in time, this is not implemented yet, but these are things that can, in theory, be done.
So based on what you said, that it's guided by the knowledge that we as human put as an input, maybe I want to ask you a second question on that. Is it possible that we select the source of truth, or like where this agent should be looking for real information? During the last 2 days, there were presentations saying there are some mismatches or inconsistencies between databases, et cetera, et cetera. So can I influence the way the source of truth is looked upon from that agent's perspective? Can I say something like, if you see information in the RPKI system, this is your go-to. Otherwise, please go to the authoritative database. Otherwise, look at blah, blah, blah.
Yeah.
Is that something that we can do?
Yes, in theory, that's something that can be done, and that's something that will be built in. So there are 2 ways to actually do that. The first one is based on the tools that you configured for it. So for example, if you're only configuring the WUI's MCP or the RIPE-Stat MCP, it would, so that would be the source of truth for it. It won't go to any other source, because like I showed, when you ask it the question without this tool, it responded that I don't have this access, and this is what you can actually do. So that's one way to actually kind of like configure the source of truth that it can work with. And this is currently possible now. The other way is agent template. That's something that will be built soon, which is similar to what I said about using the knowledge that you as a human have to actually guide it. So with the agent template, you can actually kind of like give it like some hard rules that it has to follow, whichever way. And then that will guide its action.
Marco is slowly creeping up to us, so I think we're standing in front of lunch. So we can continue later. Thank you.
Thank you very much.
Thank you so much. I was just going to say the only one between AI and HI is chat now. And with HI, I mean the human interaction we will have over the lunch. So have a nice lunch break. And thanks for attending the session.
Welcome back after lunch. Through to our final sessions of the day and of MENOG. So thank you for staying with us. Hopefully you've all enjoyed lunch. We have Aftab here, who's going to talk about IPv6 and new ways of deployment. So hopefully you'll enjoy the session and get some good information out of it. Thank you.
All right, everyone, hello. I got another shorter straw to present after the lunch. So let's see if I can keep you awake. My name is Aftab Siddiqui. Today I'm representing my employer, not like yesterday where I was representing many other hats. So I work for APNIC Foundation. It is not the RIR. It is associated with the APNIC RIR, but it is a separate entity. We do a lot of development projects in the Asia-Pacific region predominantly. And have started some research-based activities as well since I have joined. So this is something which I do it as out of my interest, the measuring the IPv6. Then what's new in it? Many organizations are measuring IPv6. Many organizations measuring many things. But as a network operator, as previously I was in the past, and I have some interest in measuring things the way it should be measured for a network engineer or a network operator. So I just wanted to share a couple of points with that. I mean, this is not a secret that IPv6 adoption is gaining traction. A lot of economies are doing really good. A lot of economies are still struggling, falling behind. We have few really good cases. For example, in the Asia Pacific, it is India doing an amazing job with a lot of their mobile users are behind IPv6 only network. Middle East is still catching up. Of course, we know Saudi is doing a good job in terms of providing IPv6 to their end users. So there are a couple of platforms which are available where you can measure how the IPv6 is moving or going along in your economy or in your region. Predominantly, one of them is the APNIC Labs. It is run by the APNIC chief scientist called Jeff Houston. He's been doing it for many, many years. It's considered somewhat industry standard for measuring IPv6 because it's based on a lot of data points. For example, it's around between 10 to 15 million data points every month. So that's a lot of numbers. Replicating this or scaling it to that level is really very hard. So that's why it has become a very important measuring tool. The only drawback with that is it is based on the Google infrastructure. So if you are using, if your users are using Google, any of the Google services, then of course they will be part of that measurement. If for some reason your network or your users are not using the Google, then there will be some discrepancy in the results. But of course, we know that everybody is, there's a big chunk of users who rely on services from Google. So that measurement number is very close to being accurate. So if you look at that number, I mean, it's that map, except Saudi, which is a bright green color. Green is good, red is bad, simple. In the UAE, it is slightly green, so better than the rest of the economies in the Gulf region. But you can see what is on the other side, on the right side of mine. It's a pretty grim picture. If you focus on UAE, so as per the APNIC measurement, it is around 51%, slightly over 51%. It changes 1 to 2% on weekly basis, depending upon the number of hits the platform gets. But you can easily say it's around 50% IPv6 capable users in UAE. And if you look at Saudi, it is much higher number. And the graph shows that the upward trend is quite visible. Something drastical happened around 2020, and it's been up there for a long time now. But there are other two platforms which do the measurement as well. One is from Cloudflare Radar. As per Cloudflare Radar, the IPv6 capable infrastructure in UAE is 40%. So now there is a 10% difference between between APNIC Labs and Cloudflare Radar. Google has its own measurement as well, which is Google IPv6 page. But that's interesting point because APNIC Labs also uses the Google infrastructure. But there is another caveat which I'll explain why there is a difference. Google says that UAE has 44.64% or around 45% IPv6 capable users in UAE. So the difference between APNIC Labs and the Google, its own measurement is based on how both platforms measure networks in their country or the economy. APNIC Labs measure everything originating from the economy. So that will include networks which are not part of UAE. For example, if you have a cloud operator operating outside, registered in, let's say, APNIC region and operating here, but it will be counted as a network originating from UAE. So that's why there's a difference, whereas Google only measure based on the country or the origin of IP, rather than the allocation of IP rather than the origin of IP. So there's a 5% difference in that. But if you want to have a look and say, okay, fine, there's 51%, 40%, 44.64%. Which number is correct? What do you recommend? The higher or the lower? Which one should be the benchmark for you? Any suggestion? Yes, I would say all of you, right? So all the numbers are correct. There's nothing wrong with any of these measurements. It's the perspective, it's the perception, and how they are measuring it is the difference. And that's the whole point of my presentation, that it's, as we call it, that measurement is hard. And that's what I learned from Jeff Houston as well after debating about these numbers for many, many months. It's hard. You cannot pinpoint exactly the same percentage. You can see there is almost a 12 to 15% difference between all three measurements. And they are all very reliable measurement, but they are doing it based on the infrastructure they maintain. So Cloudflare Radar is telling you the numbers which they see on their infrastructure. They run a huge CDN infrastructure, so of course anyone hitting their network within V6, they measure that. And they measure it on the basis of originating IP as well. The biggest difference is, you'll be surprised, all three of them use a single mechanism to calculate number of users in the country. And that platform is maintained by Jeff Houston. And it causes a slight bit of problem. For example, how many active users are in one country is hard to measure. So there are some very fancy and difficult mathematical formulas which has been used to calculate that. And that is the baseline for all three measurements. And it somehow causes a bit of a problem. So I said, okay, fine. Every measurement has sampling bias. Every measurement has interpretation and presentation bias. So let me add another one to add another bias into that one. So the point I was mentioning was this, say, if I look at the number of measurements which APNIC labs collect, so it can say that Emirates, the Etisalat, are the major players in bringing the IPv6 capable users higher. And the sample size gives you the whole idea. It's so number of sample size, the ratio of this, I mean, the percentage is calculated based on the number of sample size comparing with the number of active users in the economy. And that's how the percentage is calculated. It's a logarithmic value. So it's not 100% accurate, but it's a log value. So it gives you a very good idea about the percentage. People are very inclined towards saying, okay, this number, UAE is 51%, Saudi is 86%. All these measurements are there just to give you an idea how the networks are performing. So these are not 100% accurate, but they are just for the sake of giving you an idea. Now going back to the point that how should we measure? So going back, I mean, I started this discussion with my former colleagues, Amreesh and Max in the past, and I started building something on my own and got some very nice pointers from Jim when we met a couple of months back. The point is, most of us here in this room are network engineers, right? For a network engineer, the most important bit is that if I have the resources allocated to me by the RIR, for you it's RIPE and CC, am I announcing them or not? The most important bit. I received IPv4, I received IPv6, I got my ASN. Am I using them or not? So that's the important bit. Number two is I receive 3 set of resources, the number resources. Am I using all 3 of them? Or I'm using only IPv4 or not using IPv6? Am I using IPv6 only or not using IPv6 at all? Am I using my own ASN or I'm just using Etisalat or DOO's ASN to put my resources behind them? So that's the important bit, right? So on the basis of that, I started doing this calculation. So this is just a network measurement of IPv6 rather than the user measurement of IPv6. So in that sense, if you look at the data of UAE, for IPv6 only, all of a sudden, Saudi becomes red and UAE becomes green. And the reason for that is the number of IPv6 resource allocation to UAE are 577. And out of that, 82% are actually advertised in the routing table. So most of the networks who receive the resources from RIPE and CC in UAE are actually advertising them. But that's not the case for Saudi. And I'll show you the exact numbers in a moment. The second thing which we measure is the resource allocation. So this is the number for 2024 and 2025. So between 2024 and 2025 in UAE, there were a lot of allocations for ASN only or IPv4 only. Many networks who went to RIPE and CC to request resources did not even ask for IPv6. So the new networks coming in, for example, the last, out of 5 last allocations, the data is a week old. Out of 5 allocations, only 2 networks only requested IPv6. They did not even ask for IPv6. And then you can check again that, okay, fine. 10 networks were allocated IPv6, but are they using the IPv6 they were allocated? You can look up in the global routing table. It will give you an idea that how many are using. So it's not about just allocation. They received their IPv6, but they are still not using them. So there are multiple steps. Number one, did they ask for IPv6? Number two is, are they announcing it? And then you can connect the data with the APNIC labs and cloud radar data, that how many users are actually behind those networks. So that gives you a complete picture. But what you see with only the APNIC IPv6 labs or radar from Cloudflare, they only give you that how many users are there, rather than telling you how many networks have IPv6 plus how many users behind those networks. So I'm going to just go back quickly and try to show that platform. I'm not sure why it's not showing up. All right. All right, here it is. Right, so if I want to check the status in Saudi, you will find out that 114 allocations were made, but out of those 114, 42 are found in the global routing table. If you open up the RIPE stats and say, well, RIPE is saying that there are around thousands of IPv6, so why there is a discrepancy between that and this one? What I'm measuring is the resource allocation exactly as it was done and any smaller prefix announced in the global routing table, but I count it as 1. So if you received a /30 IPv6 from RIPE and CC, I will count it as 1, whereas RIPE and CC will count it as many smaller prefix coming out of those /30. So that gives you a higher number in RIPE stat versus here. But the number will be exactly the same. I just combine them together. Even if you are announcing a /32, single /32 out of a /30 you received, it will be a green tick here. So the numbers remains the same. IPv4, that was quite surprising. I mean, we were talking about the lack of IPv4 in the region. There are a lot of resources, IPv4 resources available in Saudi. They have not been advertised and not used. If you go into the details that who are the holders of these V4, these are the big operators, of course. So the smaller operators, if they have the V4 or V6, they do advertise them. They don't hold it. The bigger operators, of course, they have more leverage. So they keep the IPv4 but not advertising them. Similar to the case with Syria and Iraq, the numbers are very, very low for IPv6. They all have got a big number of allocations. For example, there are 210 ASNs in Iraq. Almost half of them did not even ask for IPv6. And from that number of resource allocation, only 17 to 18% are in the routing table. So that's a big difference. Same is the case, the UAE case is different, as I mentioned. Iran is same. Their IPv6 adoption rates are higher, of course, as I said about Saudi, but in terms of the network usage, the number of networks are actually advertising them is very low. And the picture is almost the same. I'm still collecting data for all the other economies. It takes a bit of time to process it, but if you want to compare it with the other economies, you will find out that the IPv6 has a similar pattern. If you want to check IPv4, you will find that it's drastically different from Middle East. So for example, Thailand or Vietnam or Philippines or Australia, most of the IPv4s allocated to them are actually in the global routing table. But that's not the case in Middle East. So most of the IPv4 allocated are actually not in the global routing table. So a lot of it is still sitting as reserve in most of the economies. ASNs is pretty much fine. Australia is a bit odd because some networks have received hundreds of ASN in the past. It's before APNIC, so they just hold it for no good reason. But ASN is fine. Most of the ASNs which have been allocated are in the global routing table. IPv4 and IPv6 is there. IPv6 pattern, you can see it's almost similar across the world. Whatever I have published here. So you can actually go to IPv6deploy.net and you can check yourself. Most of the calculations are done on in your browser, so it takes a bit of time. I don't have enough resources in the backends to do all these things. Don't start checking everything right now, otherwise it's going to crash. So you can pick up anything. For example, UAE, you can say how many allocations were made in 2025, and it will tell you that one network got a big chunk of IPv4 as well. Probably a transfer. But the numbers, you can see a lot of ASNs were allocated. And these networks did not even ask for any other resource. I'm not sure why there were a lot of ASNs allocated to them. And they are based on, you can check who are these. So I have not published their names because finding the real name of the organization is a bit tricky. You can publish the AS or the org ID, which doesn't tell you the exact name. It's probably smaller or shorter, so I haven't figured out if you have any suggestion. I was looking at using the Team Cymru one, but it also gives you a smaller version of the name, which is not very accurate. So so that's still I need to resolve. So if just help me with that. You can select any other economies you want. You make sure if you are checking any economy which exists in the RIPE NCC region, you put RIPE NCC. If it is APNIC, you put APNIC, ARIN, or like that. So if I say in 2025, how many allocations were made in Saudi. So the last couple of them are, of course, the smaller blocks, the smaller networks. They have received the IPv6, but for example, the last one, you can see the network which asked for the resources, whether they got the transfer through transfer or whatever means, they did not even ask for IPv6. So similar case, but at least in Saudi, most of the networks in 2025 who received their resources, whether through transfer, they did request IPv6 from RIPE NCC. So they are visible, and they are visible in the global routing table. But the previous one who received it did not, are not actually using it. So there is a discrepancy between that the newer networks are actually doing the right thing, getting their resources, advertising it, but the older networks who receive their V6 blocks are not. So that's all I wanted to show here. It's just an attempt to add another plug into the IPv6 measurement, that how you can understand better, that just looking at the number of active V6 users is not the full picture. As I mentioned, as network engineers and network operators, it is our duty or responsibility to make sure that other fellow network operators are doing the right things. They are able to advertise those prefixes as well. And something which we focus on quite extensively is what we have seen in those numbers from APNIC Labs and Cloudflare, that the larger operators, the big operators, are driving the V6 measurement numbers. Same is the case with India. I mentioned to you that India is sitting around 86-87% IPv6 capable. But if you remove the top two network operators there, which is Reliance and Bharti, the numbers will drop less than 30%. So the smaller networks are actually not deploying V6. The smaller networks are not even advertising V6. So the big operators are actually hijacking these numbers, and everybody says, well, India is doing a great job. They are, but not everyone is doing a great job. So same thing is with Saudi, or same thing is Salat and Do here. They're doing an amazing job. They should be acknowledged for that work, but that doesn't mean that everybody else in the economy are doing the great job. And that's our responsibility, to make sure that we help the smaller operators, whether it is training, whether it is understanding of how IPv6 works, and things like that. I mean, for example, the network we have in this venue doesn't have V6. So maybe a helping hand would have been amazing to say, okay, fine, what can we do to help you bring the IPv6 in the venue? So it's smaller things like that. Just to close this topic, as I mentioned, measurement is hard. Any measurement will never give you a hard and fast source of truth. Say this is the source of truth. No, it gives you an idea, and then you have to then find more details yourself. Please don't rely on a single measurement saying this is perfectly fine as long as it is green. Make sure that you understand how those measurements have been done. With that note, if you have any question, please let me know. This is an attempt. This is, I would say, a beta version. I'm still trying to improve it, so any feedback is welcomed. Chad.
Please, Chad. Yeah. The mic's not working. Can we get the mic, please?
No.
Okay.
Yes.
Jad, RIPE NCC. I have 3 comments for you. If you can go back to the slide where you were showing the different measurements, like one from Google, APNIC, etc. I rely on this a lot. I have to deal with it a lot because part of my job in the NCC is to try to go around the region here and try to convince everybody, the regulators, how we can push for IPv6. And I get shown these statistics all the time. But in fact, not all of them really explain what they are measuring. So for example, in the last report that was issued on the adoption of IPv6 in EU by the GRC, which is the Joint Research Center at the European Commission, they tried to explain a little bit what these measurements show. So for example, Google, for them, shows the percentage of people trying to access Google services. But it doesn't reflect that this is the actual traffic. whereby, for example, Akamai, they showed the actual traffic. So it could be that there's 10% of the users who generate a lot of traffic towards Google. So while the numbers are 44 or 46% or whatever, it could be that the real traffic is different. So I have a question for you here. What do you think is more reliable, measuring the percentage of users or measuring the actual, volume of traffic, which can be two very different things? So that's my first comment. The second comment for you is if you can go to the global routing map, the one, for example, if you can open it for the one in Firefox, and shows the IPv4. You said there's a lot of IPv4 not being used here in the Middle East. I'm very perplexed. Next week we have the government roundtable at in Cairo for the Middle East, and I try to compile some data about the usage of IPv4. And I use Jeff Houston's platform, Potaru, for that, but I look at the number of /32s, which are the individual IP addresses that are given to a certain country, and then the number of /32 advertised. And out of the 12 countries, 10 in the region here advertise more than 90% of the /32s. Again, as per Potaru's platform. So for example, in Saudi, there's almost 11 million IPv4 addresses given, again, as per the platform, and 10.3 million being advertised, again, as per this platform. This is considerably different than the average that you're showing. Could it be the case that here you're counting the allocations per se, and then a lot of the big operators, they have a lot of address space, so a /10 or /11, and I've seen these in the region, are considerably more than a /22. And if you're counting the allocations, maybe this is why we see this discrepancy?
Yeah, so I mean, let me answer both of them. So first thing, yes, it's allocation. I mentioned it clearly. These are allocations. Because if we only focus on the number of IPs, which it is done by Potaru and presented on REX, which is the Resource Explorer at APNIC, they measure number of individual IPs on the IPv4 and /64 on the v6, which gives you a huge number of IPv6 as well. They measure on the number of IPv4, but the problem with that measurement is if you are advertising, if you have a, let's say, /22 allocated to you, that's 1,000 IPv4 addresses. And they only look at that without looking at the announcement. They don't look at the announcement. The second problem with that is what I am saying, if from that /22 you are advertising a single /24, I will count it as yes. It's a Boolean response. So I'll count it as yes because you received an allocation, you advertise it, whether it is part of it or not, you advertise it. So yes, it's totally different measurement. One is based on allocation, and the other one is on the basis of number of individual IPs. So yes, that's different.
But if I see on their platform something that says, 10.3 million IPv4 addresses out of the 11 millions in Saudis that are allocated to Saudi are visible in BGP, then can you really say something like most of the IPv4 addresses are sitting in reserves? This is the question that I'm trying to figure out.
Okay, so I do not run Potaru. I do not represent APNIC.
I know.
Or neither Jeff Houston, but I can have a look at that one because what I know about that measurement platform, they do not look at the individual announcement in the global routing table.
Okay.
So the REX is based on total number of IPs allocated, and that's it. They don't check globally if it is in the routing table or not.
I'm just saying this because my personal experience here in the Middle East that we have been squeezing every drop of IPv4 since we can. At least I can speak of a few countries like Lebanon, my home country as well. Like if we had something, we squeeze it out. Anyway, yes, we can talk about this.
And if you want to get more details about this data is actually available right now. You can just go and then you can do the show table and then it'll give you all the data that which network is actually have the v4 and which is not advertising it.
Last thing, one last comment around the IPv6. I think the IPv6 is becoming a little bit the victim of its own success in the sense that you get a lot of address space. In IPv4, the majority of the IPv4 address space was in the hand of the operators, right? The LARs, the other LARs might have a little bit of space. But now in IPv6, if you take a look, for example, here in Etisalat, here in the UAE, you might find Etisalat and Do having a /29 each, but then you'd have 70, 80 different LARs, smaller LARs, who might never do BGP or so on. They just requested their /29, and then we'll see, oh, there's a big address space that is not being used. In retrospect, when Etisalat or Do might go and connect these customers of theirs, instead of having to do BGP for their customers using the customer's IP address, they would say, oh, I'm going to give you a /48, and then you have 65,000 /64s. Go knock yourself out. So while the numbers in IPv6 are a little bit worrying in that sense, because I also take a look at the ROA signage, for example, for IPv6, and it's always much lower than IPv4 globally. And I think because of this.
Jad, if we could wrap it up, please.
Yeah, sorry.
We are running over.
Yeah, so that's just a comment that we have to be a little bit understanding of how IPv6
I absolutely agree in principle with that. Just to sum it up, these are all the nuances in any measurement platform. We just need to be aware of them. That's my whole point. And your point about the whether we should be measuring the traffic versus the active users or versus the allocation, it should be all, right? Nobody right now. The problem is no one is willing to share the actual measurement, traffic measurement, other than the network operators themselves. They can share it, otherwise no CDN is going to share it because they consider it proprietary. So that's the problem. So combine as much as possible to give a clear picture is my opinion. Yeah. Thank you.
Thank you very much.
Thank you.
Aftab, very interesting presentation. Lots of good data points. We still have quite a way to go, obviously, in the region on building on this. And carrying on with the same topic, but more of an AI approach, Yasser is here to talk about IPv6 adoption using AI. The floor is yours.
Thank you. Oops, we go back. All right, good afternoon. So AI has changed the way we do work, driving unprecedented speed and efficiency. Today we will see how AI can help us accelerate IPv6 adoption. My name is Yasser Zamir. I am currently employed as Senior Network Planning Engineer at Infonas from the Pearl Island of Gulf, Bahrain. And I have successfully worked on multiple core ISP, cybersecurity enterprise projects, and of course, one of the team members who implemented IPv6 in our organization. So let's set this a familiar stage with an analogy. So IPv4 address space is like a giant parking slot, and the LLIR, which are represented as cars, need space to operate. So as you can see, that space does not exist, and there are cars queuing up for, vying for space that might not be there. We have used up every spot in the IPv4 parking lot. So IPv6, on the other hand, provides 340 undecillion IP addresses, which is more than the sands on the planet Earth. And when we are done with the planet Earth, then it is about every known star in the galaxy. But designing and implementing IPv6 is challenging and can be challenging. So in this, we would like to see what is the IPv6 adoption in the Middle East. Now, I would like to reference the post that was published last year by RIPE NCC, discussing the different aspects of the internet building future-focused internet in this part of the region. And it calculated or measured the IPv6 adoption on two metrics, or two nuanced metrics. The first was the IPv6 capability, which is the network readiness of the infrastructure, and then the IPv6 adoption. IPv6 capability was defined as that an autonomous system advertising at least one IPv6 prefix, and adoption was the actual utilization which was going to the CDN. So these were the two metrics that was used to see the measurement of the IPv6 progress adoption, IPv6 adoption in the region. And this is a snapshot from the article. So as you can see that Qatar has almost 60%, but overall the region, the capability is at average 25 to 35%. There is an updated post just before this year's MENOG, and the capability is similar. It has not yet, it has not progressed much further from here. So this is the causal gap, which is the IPv6 capability always precedes IPv6 adoption. It is the necessary investment required before the actual end user utilization will take place. It's like driving a car on the road. If road does not exist, then there's no traffic. So what are the key challenges in IPv6 adoption? It could be legacy. It starts with legacy infrastructure which does not support IPv6, especially the critical ISP infrastructure that supporting legacy or some critical services. It could be financial barrier leading from the legacy that, we have lots of investment in infrastructure and training people and so on and so forth. And last but not the least, the dual stack, because definitely it cannot be shut off and starting. It will be a dual stack scenario. So it can create operational complexity for the operation teams. But what if now, the team members have been attended and, and have buy-in in the RIPE NCC's evangelism, and they have made a plan for phasing out legacy infrastructure, and they have set out a budget, and they are now committed that yes, we have to take the necessary move that is coming eventually. So we are left with this complexity of implementing IPv6 without compromising on performance, which will require deep expertise and also an immaculate planning and operational and skills to handle that operational transition. The inevitable question, where shall we start? Do we hire expensive IPv6 consultants? Do we send teams on months of training and then reduce the operational capability of the organization? Or do we risk making architectural mistake, we just haphazard do something, and that can haunt us for years, because if you don't measure thrice and cut once, and you don't do that and directly implement it, it can be a disaster, because once it's operational, then we need maintenance window and so on and so forth. So in this, I would like to say that we can avoid all of this dilemma by utilizing the LLM and AI, what they can give it to us. And this can happen not someday in the future. This is possible right now. But before we talk about before we see how it can do things for us, let's just scratch a little bit surface and let's see what it is. So an AI is a software that can reason, think, and solve problems like human beings, but yes, it's not quite there. And it is trained on thousands of data, millions if not thousands. And it understands human and technical language. So it acts as a perfect translator from a high-level idea to the low-level technical details. And the question will be why it matters for IPv6. Okay, yes, AI can do all these things. How can it matter for IPv6? AI works on 3 principles. The first one is the context. It is the long-term and short-term memory for artificial intelligence, regardless of what AI it is. And unlike the stateless chatbots that we are used to, it remembers the context. So if you can give it a role, and if you give it a scenario like senior network planning engineer, it will remember that, and all answer will be in that context. And it builds on your conversation as you interact with it. The second thing is standards. So this is your RFCs. This is your RIPE policies, for example. So not only it will give subnets, it will also take into consideration the security implication, BGP implication, if we ask for that. And last but not the least, speed. So it squeezes down the schedule. So once the prompt is in, it will crunch the information. I won't say database, but it will do it operation, and the output will come in minutes, if not, and we are expecting, and if you do it manually, it will take weeks, but it will come in minutes. So combining with these three principles, artificial intelligence is poised for accelerating IPv6 increasing capability in much shorter time as would have been traditionally possible or been done. So now AI is like a brilliant network engineer or brilliant network architect. The questions has to be asked correctly. If you ask vague questions, you will get vague answers. Which bring us to prompt engineering. Now you might say that we have interacted with AI, and we got horrible results. And I do agree with you. And it is often overtaken or not been discussed in IPv6 presentation. It's not the complexity of the question being asked, nor the experience of the engineer, not the LLM that been used. It's about asking the right question and the art of asking AI right. So prompt engineering, the second level of the prompt engineering, there are different frameworks that a user will use to interact with the artificial intelligence. The first one that I would like to highlight is the RTF one. It's a very famous one. It's a very well-known one. And it is great for precise single-step results that you will use it immediately. So here the example that I have selected is a travel guide who is working in UAE, and he has to have a sales pitch. So here he will do is act like a friendly travel guide, where he has to summarize the rapid growth of development in UAE since 1990s, focusing on its transformation. And now the format will be deliver a welcome conversational introduction, followed by a list of 3 impactful facts using bold headlines. So this will be specific, will be for content. Now, it's another well-known framework, which is STAR framework. And people who are preparing resumes, they are well-known with this understanding of STAR framework that they're using, is that it has to be situation, task, action, results. It is also amazing for prompting AI because it is perfect for specific circumstances and actionable items and the results that are really focused. So over here, the scenario is that I'm an engineer and I have 50 gig of traffic that I need to transfer from one place to another place. And I'm asking, or I would like to know which protocol I should use, UDP or TCP. And I need the action is that it has to take into consideration the reliability, the overhead, so on and so forth. And the result has to be in table format, concluding with single sentence what AI thinks that should be chosen. So this is the STAR, the second framework. But the framework that we are interested in is something called CRISP. Now, it is not a well-known framework, but it follows a well-structured approach to prompting artificial intelligence, where we set a contextual environment, and then we give it the technical constraints, and then we give, of course, the input and structure, but we also give parameters, and parameters over here is the boundary. You should not go from here. So here, and you explain through example, here the examples that I have selected is like a basic subnetting situation where the requirement is for 500 hosts, and now the role that is being given is like you're the IPM specialist who works with the IP addresses, and then the supernet is like a private address spacing is /16, and it has to give all the basic things, the CIDR notification through structure, and the parameters, which is the restriction, is it has to give us the smallest possible CIDR mask to meet the requirement. So now with this, it set the stage for how we will use to design what they call it, the hierarchy, obviously hierarchy for the organization, then a basic example for the infrastructure aspect, and then the ripe objects. So we'll start with the design aspect, because here how everything designed, the first part of the measurement. So so the background is that I have selected a company name called Acme, it's like a placeholder, which received a /29 from a RIPE NCC or whichever IRR they are operating in. And of course, it's difficult to read through, but they have to, they got a /29, and now they have to work with it. They have 2 data centers. So it'll to give the idea that it's not just one data center. So the role is senior network planning. Actually, we give it a role which is precisely with the hierarchical IP addressing expertise. Then, of course, all these details that, we are specifically saying that, per data center, you should use a /32. And it's something that, if you're following rapid latency training, that it's recommended that for one data center, of course, it's not a fixed rule, but as a guidance. So per data center, a /32 from the /29, because /29 will give 8 /32s. And then for the customer requirement, DIA customers or direct internet customer, they will get a /48. They should, and ADSL will be a /56. And IP transit will be also a /48. Just simple, keep it simple for demonstration purposes. And then the structure, provide IP addressing hierarchy table showing DC location, customer segment breakdown, infrastructure interconnect subnets, reserve address for both, and output in table format. Now, the parameter restriction that I placed was to follow the RFC best practices and maintain a clean aggregation. So let's see how the AI gave me the output. Of course, because the data that comes out of AI is huge, so rather than showing it to you live and then we go through the output, so I took my experience, converted into visual, and I'm presenting it to you. So here is like a well-known IPv6 documentation IPv6 address, /9. So from this, there are 8 subnets. So the first subnet, as you can see, highlighted by red, which is for the main DC, and 9, which is for the DR site. Now from the main, okay. The first subnet that it gave us for the infrastructure, which is /36. A second one was for DIA, /36. And IP transit customer also /36, and broadband customer also /36. They are all hex spaced. So when I queried or basically prompted the AI further, it gave me the reasoning that why it selected /36. And the reason is, the next slide, that it gives the, based on my prompt, it gave me a /36 because a /36 can give me 4,096 /48s. So I can give that many customers, so on and so forth. It is equal for all the infrastructure, DIA, IP transit customers, as well as the broadband customers, and then each broadband customer, also each /48 will give me 256 /56. So it has given me through that just by a couple of prompting. And then, of course, with the prompts, you can remove this column, that column, and can give you that result from the design perspective. From the config aspect, I have selected to demonstrate the core side of it, where this will be a bit more technical part compared to any other part of the one, because it talks about the configuration. The configuration which was selected over here is pertaining to most of the, not most, but many ISPs use VRF in an internet. So they already have like a core MPLS infrastructure, but it's only IPv4, not IPv6. So here I'm giving a role where, or giving a context where it is a VRF, internal VRF design based. And of course, the role has to change so I can get better output. So senior IPv6 network architect with IPv6 implementation expertise, and 6PE, which is one of the transition method from IPv4 to IPv6. And of course, gave it placeholders, IP addresses, and autonomous system, because even though there is some sort of privacy, but it's better to use placeholders, especially when you're interacting with public LLMs. And then the structure, IPv6 interface configuration, 6 ECT between Azure and customer router, IGP, MPLS routing config, and customer facing interface. This is the whole prompt. Then, of course, the parameters that it has to be in XR format and basic security, basic relevant descriptions, provide clear routing identification, enable IPv6 routing protocol. So from this, this is something that I would like to highlight based on specific experience, that when it comes to networking configuration, network aspect, AI tends to hallucinate. So the best results that we do get out of the artificial intelligence, regardless of LLMs, is if you have a documentation of that particular part of the procedure to implement that configuration for like 6P or VP or whichever things, if you upload that with the prompt, that LLM will start preferring that instead of its own database. So the results of the configuration becomes more precise. Because if you depend on its brain, it can hallucinate and it can give you configuration will never ever work. Maybe not even supported by any vendor that you are using. So just to show as a demonstration that I got results, a couple of more prompts, and then I got results for interface configuration, just like how I would like to have it. Then IGP OSPF, because still going to be the IPv4 core, and then on top of it going to be the IPv6. And then of course the VPN4 to support the IPv6 over VPN4 implementation. Okay. And the last part, which is the ripe objects, because once you have the design and once you have the config, in reality, once the design happens and it gets through some filtration and gets approved, then the second thing is the ripe objects and then the configs. But just for mainly maintaining continuity in this presentation, I have taken this path. So over here, the role. Of course, roles was adapted based on the context. So create production-ready ripe database objects for ACME IPv6 allocation and routing announcement using addressing design above. So it's maintaining the same context. So of course, ripe database administrator with object creation and submission expertise. And of course, I'm deliberately giving it the maintainer, deliberately giving it the int num status assigned. And of course, technical detail and notify to to force that don't use the database. I need these things in my results. And then the structure, int num6 objects, route 6 objects, and required cross-reference attributes, proper formatting for database submission, and strict ripe database parameters will be strict ripe syntax compliance, include all mandatory fields, proper object relationship, ready for direct submissions. So here is an int num objects, but here is some mistake, or not. There's an error over here that I would like to tell you, or show it to you. You can see that the first part is assign, but here assign PA, which is actually does not exist in IPv6. So even though I was trying to come multiple times prompting the AI that hello, it's assign, not assign PA, even it was giving me the same assign PA. So I had to show it over here that it cannot be blind trust. It has to be human in the loop, as other gentlemen said in the early part of the afternoon. So this is the route for objects. Nothing really fancy. The fancy part is that. The time that it took to get this output, because I've been working with the ripe objects and I've creating, deleting, updating, the time has shortened considerably. I used to take maybe hours to get things done, although I'm fast, but with this it was maximum 15 minutes. So this is the transformation moment that. In span of minutes, we got IPv6 hierarchical addressing with all the consideration that we gave it to it. We got near production-ready configuration, which can not go directly to the production, although we say production, but of course there will be a POC environment where they will go, we will make sure it is tested properly without any errors. It's working fine, it gives us the results. And last but not least, a ripe database object. So once it gets approval that yes, it's well designed, it makes sense, and we should go further than this. It gives us the ripe objects. So now a junior engineer, he can function like like a senior. Actually, he can function like even more than that, but he can, in this context, function like a senior architect engineer. Small team can do work of departments, and also in the short time. The IPv6 is inevitable, and the timelines, of course, we see it's urgent, and the tools are available. So the question is that, will you lead the implementation or wait 5 years for catching up? Well, my answer is, of course, you definitely lead the process, and it will be interesting to see how you do it. Thank you so much.
Thank you. Do we have some questions? I'm sure there are a few.
Sorry, Jad, Tripe NCC. I have a philosophical question.
Yeah.
You ended up by saying that with AI, junior network engineers are going to act like senior network engineers. Back in May, there was a Harvard study. It was a small study to see if AI is dulling our mind. And they saw there are some indications that people are getting more productive, but less motivated to learn. So if AI is doing everything for us, can we really talk about senior engineers? So are network engineers from now on going to walk with an AI with them? And every time somebody asks them a question at 3 a.m., hold on, let me ask the AI. So junior engineers, yes, they can use AI to get answers as if they are senior engineers, but I don't think they'll ever become senior engineers if AI is going to take all of this. When I started studying, we were doing subnetting by hand. By the time I finished university, there were tools to do automatic subnetting. And then now we have AI doing subnetting for us, or these addressing plan. Should we shove AI down everything, down the throat of every single thing that we can do?
Yes, it is a philosophical question, definitely. I come from the same roots as yourself, working manually, working on papers, subnetting. It was questions on CCI and ECD.
Sure.
It used to be. So nothing, okay, then it comes down to if he's, so now I will split my answers into, if the individual is an adult, like ourselves who's conscious, he has to make a conscious decision that instead of me just taking it forward, I have to go through that process itself, that how AI has AI has come to that results. So I do my due diligence, I study, so that not only I get my work done, which is of course first, so I get paid, but also I evolve as a human being and as a skillful person. So one has to be fully involved with this. But as for younger kids, because you asked this question, the younger part, it's the teacher's responsibility and parents' responsibility that we create an environment where AI, yes, it helps them to do things faster, but also the emphasis has to be on the critical thinking.
Well, there are indications that it's going the other way around, but yeah, sure. Of course, I agree with you.
Yeah.
Thank you.
Because it was a philosophical question, of course.
Any other questions in the room? No? Great.
I'm also a father. I'm going to say the piece face the same thing.
Excellent. Well, round of applause, please.
Thanks so much.
Thank you for the interesting presentation. I think we're going to hear a lot about the subject as the months and years progress on AI, right? So it's definitely a hot topic that's growing in our sector and will be in many other areas of the world. So next up we have Thomas in the room. There we are. He's going to talk about routing visibility and well, best ways and practices of doing it. So Thomas, the floor is yours.
Thank you. Good afternoon, everybody. So today I'm going to talk about BGP, BGP monitoring, and BMP. Okay, so you probably all know BGP. It's the main inter-domain routing protocol used today. And it's very important with BGP that we collect BGP routes from actual BGP routers. So we can build monitoring tools like Looking Glass, as you can see here, or hijack detectors, route leak detectors, and so on and so forth. So historically, there are three platforms that collect BGP data from routers and then share this data with the community. It's RIPE-RIS, RouteViews, and PCH. And for instance, RIS and RouteViews, they connect with about 1,500 BGP routers, and then they share the data. So we call these routers vantage points as well. And today, I'm here to introduce you a new BGP data collection platform that is called BGP Routes.io. It's a platform that we built recently at the University of Strasbourg. And we say it's a new platform because we just launched it a few months ago. And probably you wonder, why did we decide to build yet another BGP data collection platform when there are already RIPE-RIS, RouteViews, and PCH that seem to work rather well? Well, the reason is because BGP Routes.io has a fundamental difference with these platforms. With BGP Routes.io, our primary goal is to prioritize coverage as much as possible. even if that means maybe discarding some data eventually when we don't have the capacity to store it. On the contrary, write and rod views, for instance, what they do is they really want to keep the data forever because this is very useful for researchers. But that means sometimes they cannot peer with some routers because that would just generate too much data. We also say it's a next generation platform because, first of all the data that we collect is publicly available, and it is also accessible very effectively. In fact, with BGP rods.io, you don't have to download and process tons of MRT files because in processing these files, it's annoying, it takes a lot of time. So instead, what you can do here is you can just use an API, which is simple, flexible, and fast. Basically, you can just query and get the slice of the data you need. You don't have to download irrelevant data anymore, and that makes the thing much faster. If you need real-time data access, it's also possible to connect to our WebSockets stream, so you can get real-time data as well. Of course, we also have an MRT archive. If you still want to process MRT file, this is fine, but we recommend instead to use the API or the live WebSocket stream instead. We also provide new interactive dashboards because perhaps you don't want to code and to use the API yourself, and that's understandable. So this is why now we are developing dashboards. So for instance, today we have 3 dashboards. We have a Nice Explorer, so you can see the details of the autonomous systems. We have a Prefix Explorer, so this is like a looking glass. And we have a Vantage Point Explorer. This is just to really check what every vantage point sees. Okay, so these dashboards, they are all publicly available. You can check them out if you want. And third, what we are also doing is we aggregate the data from all the public repositories. What does it mean? It means that aside from our own peers, we also get the data from Rypris, RodViews, PCH, CGTF, which is a small platform in Asia, and we put everything into one single database. Okay, so when you use our API, for instance, you can get all this data. In this map, for instance, you can visualize all these vantage points where they are located. And the good news is that there are some regions in the world which have a lot of vantage points. There are also some regions which lack vantage points. And that makes the perfect transition to the rest of this presentation, actually. Because in fact, even when we aggregate the data from all these platforms, it's still not sufficient. In fact, only about 2% of the autonomous systems, they peer with either BGP rods.io, Rypris, RodViews, PCH, and CGTF. That's not a very high number, okay? So here, for instance, this is an example in the Middle East. We typically lack vantage points, okay? So what does it mean? It means that, for example, when we look at the dashboards, when we want to detect hijacks, when we want to have an accurate looking glass, well, perhaps in this region of the world, we might miss some important events. And this is also why I'm here today. It's to try to motivate people to install more and to connect more with these platforms. Okay, so now in the rest of this presentation, I'm going to show you how we hope we can increase this coverage with BGP rods.io. So first of all, I'm going to explain you why it's actually challenging to increase coverage. And then I will show you why BMP here can help. And finally, I will show you that if you're interested, you can connect with us with BMP. It's very simple, and you can also use the data. So why is it hard to increase coverage? Well, first of all, it's hard to motivate operators to share the data. In fact, when an operator connects to BGP rods.io, for instance, we don't really see the impact directly, right? It's a collective effort. It takes time to make all these monitoring tools more accurate. And also, we don't really see what we are missing today, right? Because we just don't have the data. So it's kind of hard to really highlight and motivate operators to share data. And of course, it's also an effort for them to set up a session. We need to install it. We need to maintain it. So that's also some overhead for the operators. But even when we finally convince an operator to peer with a data collection platform, there is another problem, which is that only a small fraction of the BGP routes are going to be announced to the platform, because typically BGP hides routes. Okay, and this is very important, so I'm going to show it in a little example here. So if we assume that this is a BGP router which has 3 peering sessions with IS1, IS2, and IS3, so that routers receives BGP route updates from these peers. And when these updates, they arrive to the router, first they go through the inbound filters. Then the routes that are permitted by these filters, they go through the decision process, and then the RIB is calculated, and then the best paths are announced to the peers only if they are not discarded by the outbound filters. Okay, so this is the typical BGP processing pipeline in a BGP router. Now, if this router is connected to a data collection platform like BGP-routes.io, what happens is that this data collection platform will receive the best paths that are not filtered, because this is what BGP typically announces over a BGP session. That's good, because this is useful information. However, there are also routes that are not announced over the BGP sessions. Those are typically the routes that are denied by the filters, and also the alternative routes. They are also not announced over the BGP sessions. And this is really a pity, because the operator is willing to share this data. It's just that this data is not shared over the BGP session. And it's a pity, because in this set of routes, maybe there are hijacks, maybe there are route leaks, but we just don't see this data, so we cannot detect these events. Okay, so now I'm going to explain you why BMP can help. So BMP stands for the BGP Monitoring Protocol, and it has 2 advantages compared to BGP when used for monitoring. First of all, it can export all the routes for every peer, so we can really configure it at the per-peer granularity. And besides, it can also export the routes at every stage in the BGP processing pipeline. And besides, it's also very simple to configure. So what does this mean? Let's take our previous example. Here, we see there are 5 stages. The first stage is on the left. It's really before the inbound filters. It's all the routes updates that are coming. That's the first stage. And then there is another stage after the inbound filters. And then there is a first stage, which is called the local RIB. This is just the best path in the RIB. Finally, there are 2 other stages before and after the outbound filters. So now, if the operator configures a BMP session between this router and a data collection platform, it can really decide, configure for which stage the router should export routes. It can be just for one stage. It can be for multiple stages. This is all configurable. In the context of BGP-routes.io, we recommend to export the data for the AgIn-Pre stage. This is the stage on the left. Why? Because this is just where we will see all the route updates before they are filtered, for instance. And if you do so, it will also prevent users to infer your routing policy. So that's also something else that you would like. So now what happens if the operator exports the data at this stage? Well, the collection platform will receive the data as it comes from IS1, IS2, IS3. So it's really like if we had 3 BGP sessions with IS1, IS2, IS3, it's the same data, but instead of having 3 BGP sessions, we have now 1 BMP session. So this is really where BMP is sort of magic. It's less efforts for operators, more data for users, and this is why we think that this is the way to go. Okay, so if you if you are convinced, you can connect to BGP-routes.io with BMP. It's super simple. It's fully automated. You just go on the website. You click on the login button on the top right corner, and you can authenticate using PeeringDB. Then you click on this red button, start peering with us, and you will see this form. You just have to fill up this form. It literally takes 2 minutes. You submit, and then when you have submitted the form, you just have to configure BMP in your router. It's just a few lines of configuration. We even provide examples for every vendors. And then soon after, you will see all the data in our dashboards. So now what if you want to use the data? As I was saying, it's all publicly available. So what we try to do here is we want to make the collection protocol actually transparent to the user, because when we use the data, we don't care if it has been collected with BGP or BMP. And this is what we did with, for instance, the API. So imagine you want to build a looking glass with our API. So you can use our Python library, which is called PyBGP-routes API. And you just take the vantage points function first, and you say you want the vantage points from BGP-routes.io, from RIS, and from PCH. And then with these vantage points, you just use the RIB function. So you give this vantage point as input, you specify a date, some prefixes, and you will get the entries in the RIB at that time for these prefixes and for these vantage points. And it does not matter if these vantage points are from a BGP session or a BMP session, it's just, in the end, BGP data. In our dashboards, it's the same story. So for instance, this is the vantage point explorer. So on the left side, you have the list of autonomous systems that actually provide some vantage points. So if you click on one of these autonomous systems, for instance, here, the last one, FiberB, it's an IS in Denmark, and FiberB is connected to RIS, to route views, and to BGP-routes.io. And then you can click on these vantage points, and you can see some details, you can see some statistics, some graphs. And here, it doesn't matter if this vantage point is BGP or BMP, it will be the same data, same graphs, same statistics, same story. If you really want to learn more about BMP and you just want to see the data from BMP sessions because for whatever reasons, it's also possible. So on the VP Explorer, on the top left corner, you can actually group VPs by BMP parent ASN or BMP feeder ASN, it's the same thing. And here, for example, you see the 5 BMP sessions that we have for now with 5 different autonomous systems. And the first one, for instance, this is Nokia Labs, and they are connected to BGP-routes.io. And one single BMP session that we have with this IS actually brings 110 vantage points, right? And this is where the magic happens. So if you click now here, you see all these vantage points that we have from that BMP session. You can see there are a lot of German flags here because we discussed with the operator, and he said that these are basically peers that he gets from DedaSense because he connected to DedaSense. So when we are connected to BMP to his router, it's like if we are connected to the peers that he has through DedaSense. Okay? And this is why we are seeing all these vantage points. That's it. That ends my presentation. So that's just a table that summarizes what I'm saying. And now if you have any question, I'm happy to answer. Thank you.
Any questions in the room for Thomas? No? That's a very cool tool. So
thank you.
Thank you, Thomas, and a great presentation. Thank you very much. So, with that, we've come to the end of another MENOG session. That was the final presentation for this year's MENOG. Obviously, we're in Dubai for this year. I'd like to welcome up Hisham, Chief Community Officer, if I'm not mistaken. So Hisham's going to give the closing remarks, and we'll go from there. Thank you.
Thanks for that, Khalil. And yeah, I also get confused with my title sometimes as well. I'm Hisham Ibrahim. I am the Chief Community Officer at the RIPE NCC. And I will be giving the closing update, and then we can release you all to your lives again and to enjoy the rest of the day in Dubai. First thing, we would like to thank the local hosts. Etisalat and they really did a great job in making us feel welcome here in Dubai, bringing this whole meeting together, and the lovely social that we had yesterday, the training courses that we did as well that were hosted here at the hotel. We really rely a lot on the hosts to be able to help us make all this happen, and they were really a great host, and I would like to invite them to the stage to come and get some token of appreciation. So please.
Try not to drop it.
I would also like to thank the sponsors that also made this happen. Your contributions, whether financial, that got your name here, but also a lot of them put forward talks and participated, whether in the agenda itself or in the day zero. So really a warm hand of applause for all of them. So. I can read them out, but we don't have something for all of them. But to mention, so the RIPE NCC, the diamond sponsor for these events. We have AM6 as a platinum sponsor. We have Flex Optics as the gold sponsor, as well as Meta. And for silver sponsors, we have DICX, Lynx, and for bronze, Internet Society, ICANN, PCH, and Smart Hub IX. So thank you for all of them. But we want to also thank AM6 specifically. So the lovely Petra's in the room, please. Now, I jumped into the slides, and maybe I should take a step back and maybe acknowledge some of the stuff that happened here in MENOG before I go through the rest of them. This event was a really, really great event. Not only in terms of attendees, which you're going to see now in a second, but also in the terms of topics. Like the sessions were really, really interesting and very on point. I mentioned in one of the comments that I said in the mic that earlier this last week, I was attending also a conference here in Dubai. It was called Knowledge Summit, where it was all about AI and what was happening there. And the interesting thing is the topics that we were discussing here was also the topics that were discussed by heads of regulators, heads of states, ministers, the chief level officers at the operators, which was quite refreshing to see that topics like IXPs were high on their agenda in the region here. Topics like IPv6 and the scarcity there. AI obviously being a theme and a driver there. So the work that's happening here is really interesting and feeding into that. And the great news is, well, this community, has been ready and gearing up for this for a long time, so it was very easy to talk about that. And to talk about what we plan and want to see in the future and how we prepare for that today. So how we're building networks today to prepare for the digital economy of tomorrow. And some of you might have met my son, Adam, who's sitting in the front row recording me at this point in time. How can we leave them with better networks and a more connected world than what we came into the world and saw? So really, this has been a great MENOG, in my opinion, and I just want to give a round of applause to everybody that's been part of it, really. So a little bit of numbers now. MENOG, we had 204 participants at the event from 37 countries. 103 of them were newcomers to the event, which was really great. We saw 85 from the UAE here, which is one of the reasons why MENOG goes around. We'd like to allow the opportunity for more people that don't necessarily travel to be able to come to the events. Very happy to see more participation from the Iranian community here. I know there's usually visa challenges for them to attend some of the MENOGs, so they're always part of the event, of course. They're always part of the community. We never make a point of defining what countries are part of what region. That is not what we do. It's always, if you're interested in development in this part of the world, you're always welcome in here. Lebanon, we had 6 participants, and then the list goes on longer and longer. Oh, we also had, I was reading the bottom line there, I couldn't see it, and I can look for here. We also had 6 very well-attended workshops and the day 0, where we sit down more with the IXPs and the peering coordinators to discuss more topics around peering and interconnection, and that was attended by 63 participants. So the numbers also show that there is interest, and we're obviously doing something right, that people keep on coming back and wanting to be part of this. The lovely photo that we took yesterday. We love these photos. It's very hard and complicated to get everybody on stage to take the photo. It's a whole thing, and then Al starts cracking jokes at the back, and people start smiling, and then we take people. But really, these photos, and when you put them together with all the regional events that we do, it really tells a story about how we're moving forward, not just as, well, RIPE NCC and the RIPE meetings, but also spreading that out across the entire service region with the regionals that we do here as well. We have a great team that supports the event. The RIPE NCC provides a lot of support. Can I ask my NCC colleagues to stand up if you're not standing up already? And please, everybody else, give them a very warm round of applause. They work very hard, not just at the event, but also in preparation for the event that takes us months in advance. And also not just the people in the room. We have colleagues back in Amsterdam that do the same as well. And really, they're the ones that make the event such a success, whether it's from the registration desk when you walk in, or the registry desk, or the different conversations that we have, to the great comm support that we have, the technical people, the trainers. It really is a great collaborative effort from across the organization that we really see and celebrate every time we have an event like this. But I wanted to really single out one person this time. And I can stop talking at that point because, there's no words to be said that would give her justice. But really, Sandra has been, I don't know, the mother of MENOG, really. The driving force. Come on, say Sandy. She's been around from MENOG 1. She started MENOG meetings. She has organized every meeting since. So all the 25 meetings she has organized. Since also a year ago or more, Sandra has become the events manager at RIPE NCC, overlooking all the different meetings that the RIPE NCC does. But because she still loves MENOG so much, she organized last year and this year. She always calls it her baby. I'll allow her to say a few words as well. But from now on, Sandra will be focusing more on the managerial aspect of things, because she now has a brilliant team. Some of you might know Hafsa and Noel. They're standing over there. Wave, Hafsa. Wave, Noel. Yes. And there's Kajal at the end, Kaj as well. They will be doing the actual organization, while Sandy will be doing more on the managerial thing. But Sandy, I would love you to say a few words.
Yeah, well, as you know, I love the Middle East, and I love doing MENOG. I do it with all my heart, and I will still be involved and attend all the MENOGs. But Hafsa and Noel, maybe you can come so they can see you. We'll do it in the future. They will take care of MENOG in the future, and I will still be involved, of course. And thank you all for everything.
Thank you, Sandra. I talked about the agenda, and I talked about the great work that we saw, the presentations, the interaction, the content, all the way to the beginning of the meeting, all the way to the end. There wasn't a session that I didn't want to sit through and listen to the topics. And that also requires a lot of people that volunteer their time and their effort to try to get these talks in, but also to try to evaluate them, work with the speakers to make sure that we don't have commercial content here and it's only relevant content that is technical and could be useful to the community. I would love to invite the program committee on stage to take a nice photo very quickly. Please, if you're in the room, you guys know who you are. I'll read the names: Khalid, Anwar, Fahad, Halil, Hannah, Marco, Max, Mehmet, Usama, Sarah, Taha, and Walid. Not everybody is in the room, but please. And everybody, based on popular demand, Jad, we want you up here as well. Jad is the RIPE NCC liaison to the PC. They are very serious people. They take this very seriously. And yes, this is where I'm hoping you take out your phones and scan a QR code. I see Nishal already shaking his head saying you should not scan QR codes, but I promise you this is safe and you're not gonna get one of those never gonna give you up things. No, we're not doing that this time. We really value your feedback when it comes to these meetings. We ask very pointed questions that can help us make them better, and we always take them very seriously. We also have an MPS score that we also report all the way to the board level to make sure that what we're doing still is on point and relevant to the community. So I like to leave this slide up a little bit so people can take out their phones. I see some people taking their phones out. I'd love to see more. So I'll let it sit for a bit. We used to just put up the slide and then expect people to go back to the slide later and fill it in. That never worked, which is why we're doing it this way now. I'm happy to see many people with their faces in their phone. And while you're finishing that, I can also start saying, next year will be MENOG 26. If you're interested in hosting a MENOG, please contact us, let us know. We make a point of going around the service region to make sure that more people have an opportunity to attend. So if you are from a country or you have business in a country in the Middle East and you'd be interested in hosting a MENOG, please contact us. We would love to be able to do one in that country soon. Just to go back a little bit in history, if I remember correctly, last year we were in Oman. The year before that we were in Saudi, before that was Bahrain, and before that was COVID, so we were all at home. But we do try to get around as much as we can, and looking forward to know where we're going next year. We also have the RIPE meeting next year. The one coming up is RIPE 92. It will be in Edinburgh, Scotland. From the 18th to the 22nd of May. It will be a great event. We would love for you to come and attend. So please join us. And if you cannot, it's fully hybrid. So you can join us on Mythical and you can attend also from the comfort of your home. And we make sure that even the remote participants get the same experience as much as we can, like the actual people at the meeting. And with that, a big thank you to all of you in the room that are staying all the way till the end. It's really great to see. So thank you all to you. The room is half full. That is impressive. On a Friday afternoon, that is really impressive. So thank you all. And now, meeting is adjourned. Thank you. And apparently there is a closing reception that we welcome you all to go and attend. Thank you.
It's on the third floor on the terrace.
Closing
reception.
On the terrace. See you at the closing.